statistical workshop on data analysis through SPSS by Population Research Center, Forman Christian College at Chartered University, Lahore. As you all know, that in order to become a qualified researcher, data analysis is very important in research. Many of the opportunities that the current market has revolves around data analysis. And we are privileged that today we have Dr. Anwar with us as a facilitator who will help you to learn the skills that are necessary to operate in research-oriented market. Dr. Anwar Mughal holds a PhD in statistics from National College of Business Administration and Economics. He has an MPhil and an MSc in statistics from GC University, Lahore. He has been teaching statistics in different well-reputed institutes since 1999. He joined FCC in 2009, and since then, many of the students, including me, have benefited from his skills. He has remained associated with many industries and institutes for quality improvement programs and trainings. His research interests include statistical quality control, Six Sigma techniques, reliability engineering, and data analysis. He has published a number of articles in national and international journals. We are very thankful to Dr. Anwar for joining us today. And now, without any further delay, I'd like to invite Dr. Anwar to start this workshop.
Assalamu alaikum, everyone. I believe everyone is hearing me very clearly. Thank you, Jawad, for your words. Uh, uh, your words are quite energizing to me. And I've seen that most of the students are, these are already registered with me, Stat 103 course. So many of the basics they already know, but I will try to repeat some of the concepts which are very important to begin with the workshop. And let me share one of the questionnaire which I usually share whenever I start with the Stat 103 course, SPSS. Now I share my screen. So can you see that case study one, creating SPSS data sheet? If any one of you could confirm that.
Yes, sir, we can see it.
Okay. So I always begin with this questionnaire whenever I take the class of Stat 103, one or two lectures in the beginning. And the purpose of showing this questionnaire is just to have a brief introduction about the variable types. It was very important to know the type of structure of the variables, because whenever we create the data sheet in SPSS, very important to know about our variable which we are going to create in your SPSS environment. So I would request all of you to keep your notepad, writing material, anything, pen, pencil, etc., what you use, and your system close to you, and preferably take the workshop over your systems instead of mobile phones, because the big screen helps you to learn more and it's create extra advantage in your learning environment. So here we have a questionnaire that is related to specimen study. I can't say it's an ideal one, but actually this questionnaire contain variety of the questions and question types which come across our researchers. So main purpose is to discuss the question types, that how many types of question we come across while doing the researches. So that's why this questionnaire is in consideration. So you see, first of all, whenever you create, for example, if we are creating a data sheet for that particular study, and we have already obtained many questionnaires from the public or the respondents, the filled questionnaires. And now we want to create a data sheet where we should enter the data for that particular study. So the question, very first question that we are going to create in the SPSS is, is in the corner of the questionnaire, and that is serial number. And that serial number is wholly solely the ownership of the person who is conducting the research. He usually assign that serial number so that the traceability is ensured for the respondent, and in case there is any problem such as the missing information or some wrong information is signed up by the respondent, so he can be contacted with this traceable serial number, and the discrepancy can be rectified through. And also to keep the record, it's very important to have a unique serial number with every questionnaire, and that is very important so far as the ethics of the research are concerned, and the traceability are concerned, and the uniqueness of the responses are concerned. So these serial number can be any numbers, a mixture of ABC, the numerics, etc., special characters, whatever the surveyor wants to include in. So usually this type of variable is, this is not a, I mean, say it's a ordinal type or nominal type or nothing else. We can't say is the type of this one. So we usually call such type of the variable as a string variable. String, I repeat, a string variable. String mean it is a mixture of numerics, ABC, special character, etc. So it has nothing to do with the nominal or ordinal, etc., etc. So when we create this variable in SPSS, we select the property of this variable as a string variable. And string variables cannot be analyzed in the SPSS. These are just to have a unique identification number for the particular row of the respondent responses. And I move to next now, which are the questions of the survey. And now the question after the serial number is your age. So you see, before discussing this variable, let us classify the variables in two sections. One is the categorical variable and non-categorical variable. It's a very simple concept of dividing the variable in two types. So how we can classify them into one of the two categories I just mentioned, the categorical and non-categorical. You see here, it's very simple. You see the questions, what is lying inside the question, that is age. And here we have age groups, 1, 2, 3, 4, 5, 5 age groups we have. And the respondent is going to encircle or may tick mark the slab where his or her age is falling. And very clearly you can see there are categories. So whenever you see the categories in the statement of the question, this question can be classified as categorical question. And similarly, if you look at the gender, we have two categories, male, female. So either of the option you have to click on and just tick mark or and circle. So again, this questionnaire is categorical. And moving next, we have a question, what is monthly household income of your family? And now blank, straight line is in front of you where you can write anything according to the family income of the respondent. So this is non-categorical question. You see, the previous two questions were categorical, but this question is non-categorical. In continuous also, you can say that's a continuous type question. And our next question is similar to the previous one and uh, two questions. That's how much you spend on the soft drink per month. And again, we have 4 categories, and you will see where your appropriate category is, and you will just encircle that option. So again, you can see the categories. So it's a categorical questions. And the third one is also, you have 4 options, and one of the options we are about to select whenever we fill this questionnaire. So again, this is categorical questions. And now you can see here an indication that up to this point, we have all demographic questions. And now everyone, I think you know what the demographic questions are. Basically, the demographic questions are the main concerned questions. Their impact we want to see, and their significance we want to measure on the remaining part of your questionnaire. And all these questions which are after this, demographic question bar, these are subject related questions. And the purpose of the demographic question is that we want to see the significance or the impact of these demographic questions on the subject related questions one by one, and we apply the tools and techniques accordingly, which is appropriate to the data. And now, after this demographic question bar, we have a question that is, please indicate your preferences among. So we have few options such as Coke, Pepsi, Sprite, 7 Up, Fanta, fruit soda, and energy drink. So here we have categories. And now, what we are supposed to do here once we fill this question is the first preference. Mean, in case we have all these types of the soda in front of us, and what would be your first preference? So you will mention over here. And if the first preference is not there, what would be then your choice? And in case the second is not there, what would be your third? So in this case, this question is again a categorical question, because the categories clearly, we have categories here, but this is a question with multiple responses. Multiple responses means in the previous all the questions we have discussed so far, the respondent was supposed to encircle or tick mark one of the options given in the question. But particularly here in this question, every respondent is supposed to give 3 responses. So you can say this is a question of multiple responses, just like you are asked that what are your favorite hill stations in Pakistan, the first preference, the second preference, the third preference, in this way. So this is a multiple responses type questions. And for your facility also is mentioned that question with multiple responses. So whenever the multiple responses questions are with us, we are going to create as many questions, as many sub questions from such variables, as many choices we have within it. For example, if we have 3 preferences here, mean the respondent is going to give us 3 responses. It means we will create 3 sub variables or 3 sub items for this particular questions. And so far as the other questions are concerned, we create only 1 variable and 1 item for each. But here, for this particular question, we should create 3 sub-questions according to the type of the question given herein. So the next one is question, please check your most favorite brand of soda. So here, just only one of the option is to be selected by the respondent. And you can see here again, we have several categories, 8 categories with us for this question. So this is again categorical questions. And now the 6th one is, people prefer to buy the soft drink from. Again, we have 4 options with us. So it's a categorical questions. And the question number 7 is again a categorical questions, because clearly 3, 4 categories are given with us. And eighth is the you drink soda with continental meal, fast food, both, etc., etc. So we have categories with us. So it's a categorical questions. And now we have categories, two categories with us: yes, no, yes, no. So all these questions are categorical questions. And now we have some rating questions, and these are Likert scale. So whenever such scale come across you, where you see the strongly disagree, agree, or you see satisfied, highly satisfied, dissatisfied, etc., etc. Such type of the legends you find in the questions. These are Likert scale questions. And most of the studies, you might have seen that Likert scale is very frequently used in designing different studies. And now this was a brief discussion where you can classify the categorical and the non-categorical questions. And if you consider the complete questionnaire, we have only one question which is non-categorical. That is, what is monthly household income of your family? That is non-categorical question, whereas all other questions are categorical questions. And now we further discuss about the categorical questions. In whenever there are categories in a question or a variable, it can be further divided to uh, ordinal scale and the ratio scale. Now, what the ordinal and the ratio scales are, we should be very clear about that. Sorry, ordinal scale and nominal scale. So the categorical questions are classified to nominal scale and ordinal scale. So one by one, I discuss that which type of the question it can be within the categorical questions. So here you see we have 5 codes here, and the code number 1 is containing the age of the respondents who are up to the age of 22, and then next is the 21 to 25, and 3 is the 26 to 30, fourth is 31 to 40, and fifth is 41 and above. So you see there is a incremental tendency here that as we move ahead with these codes, the age is increasing, or it can be vice versa, decreasing as well. So whenever there is any tendency of decreasing or increasing, that as you move along with the codes, some tendency of decrease or increase you find. So this type of the question is known as ordinal type of the question. So this is ordinal type. And then next is the gender. So gender is male, female. So keep in mind that whenever we have a question that contain only 2 categories, yes, no, male, female, go, no go, pass, fail, in only 2 categories, if we have, these questions are always nominal type. You see the binary responses, whenever there are only two responses given in question, such questions are known as nominal type. And now here, this is continuous type. You can say it's a scale, the scale variable. You can call it as a scale variable because it's a non-categorical. And the next also, this is incremental behavior. You see, as you increase with the codes, your spending is increasing. Again, it is an ordinal type questions. And this is also 1, 2, 3, 4. As you move along with the codes, your intake of the soft drinks are increasing. So it's, again, is an ordinal type question. And you see here, the Coke, Pepsi, these are brands only, and you are supposed to write the brand names. And this is nothing to do with the increase or decrease. So far as the preferences are concerned, so my preference can be different from the your or anybody else's preference. Might possible that Coke is my first preference in case the Coke is not at all any preference for someone else. So whenever such tendency is there that one arrangement is not universally applicable, then these are nominal type questions. So here you can say that this particular question where you are supposed to write the preferred brand of these soft drinks, these are nominal types, not at all ordinal. And now here you see again a question where you are supposed to select one of your most favorite brand of the soft drink. So you will just encircle only one options. So this is again a nominal type questions. It is nothing to do with the ordinal. And then we have next question that people prefer to buy the soft drink from. So these are different places where you buy the soft drink. So it's nothing to do with the increasing or decreasing. So you can say it's an also ordinal type, sorry, nominal type questions. And now here the question number 7, how many soft drinks you took last day? So it's 1, 2, 3, 4. So again, there is a incremental behavior you find in the questions. So again, it's an ordinal type questions. And the question number 8 is, you drink soda with continental meal, fast food, both 1 and 2. So again, we have, these are the choices of the foods and nothing to do with the decrease or increase. So this is nominal questions. And next, as I mentioned earlier, that whenever only 2 responses we have within the questions, these are always nominal type. So the yes, no, these are all nominal type questions. Sorry. So soft drinks in Pakistan are very expensive, expensive, not expensive, don't know. So you can consider this question as an ordinal, because you see here there is a tendency that very expensive and expensive and not expensive. So you see there is a decrease in the tendency. So you can call this question as ordinal questions. And the next to it we have rating questions, a Likert scale. So Likert scale is always ordinal. Likert scale is always ordinal. So this ends up with all these question types. And if you have any of your concern regarding the discussion we have had so far regarding ordinal, nominal, categorical, non-categorical, please go ahead and ask, because we have 1 or 2 minutes to discuss this. And afterwards, I'll be moving to the next part. Yes, anyone who wants to ask? So if no, so I just now open the SPSS in front of you. You can see and I'm just opening the SPSS. Can you see my desktop?
No, sir, there's a question as well. Someone has
Okay,
asked that what is the difference between ratio scale and interval scale?
okay. So actually the ratio scale and the interval scale, these are the scales which come under the umbrella of your continuous variable or non-categorical category. So actually the SPSS is not differentiating the interval scale and the ratio scale. If you discuss this version of the SPSS which we are going to discuss today, that is SPSS 20. But in the some advanced versions, it also differentiate the ratio scale and the interval scale. In the previous version of the SPSS, the only one category it selects, which is scale. But now they have differentiated the two categories under the scale variable, which are, as discussed by Jawad, which are interval and the ratio scale. Actually, ratio scales, in case your characteristic can be discussed in types of multiples and the divisible characteristics or multiplication relation. For example, if, for example, the salary of person A is 100,000 and the salary of the person B is 200,000, then the person B can say that you are getting half of the salary which I am getting, or the person A can say that he is getting the half of the salary as compared to the B, and we can say that you are getting, I am getting double of your salary. So in the example I have shared, if you compare the characteristic in relation of the multiples, or the half proportion, half, one third, or one fourth, etc. In case this type of the tendency is lying within the characteristic, this is called a ratio scale. And on the other hand, for example, if you take or conduct a quiz in a specific class, and one of the student is having 5 marks and the other is having 8 marks or the 10 marks, now you cannot compare their capability in terms of you see that the person who is getting 10 marks having the double of the IQ as compared to the person who is having 5 marks. You can't say like this, but you just can say that the person or the students having 10 marks is more capable as compared to the students with lower marks, or you can say that the lower marks is less capable as compared to the person who is scoring high. So you cannot compare this characteristic in terms of the multiples or the divisions. So this is interval scale. So same is the case with the, we deal the temperature. For example, if the temperature of the Murray is, for example, 2 degrees centigrade, and the Lahore's temperature is 4 degrees centigrade. So you cannot say that Murray is 2 times colder than Lahore, and Lahore is half of the, you know, half of the temperature of the Murray. You cannot compare the temperature in terms of the divisions or the multiplications. So you just can say that Lahore is hotter than Murray, or you can say that Murray is colder than Lahore. So in this way, you can compare in terms of the more or less, not in terms of the multiples and the divisions. So whenever such type of the tendency is lying within the scale variable, we call it as interval scale. So in case you need more discussion regarding it, then I explain more, but I think I have answered the question to differentiate the ratio and the interval scale.
Yes, sir. We can continue with SPSS now.
Okay. So now I share the SPSS screen at the moment. So can you see the SPSS?
Yes, sir. We can.
Okay. So whenever you open the SPSS, its interface looks like you see here in front of you. So here, one of the pop-up screen, as I am moving it uh, circularly. So here we have some of the data files where I have previously worked. Here, you see, these are the names of some of the files I have worked previously. So if you are continuously working on a project, and you are keep on working day by day, so this is basically a platform. You can directly open that data file. I mean, you can say it's a hotkey you see, or the shortcut to open. For example, if you want to open this old data, you see, just click and press the OK button. It will directly uh, open up that particular file that you want to open. So few of the previously worked files are lying over here, and it is actually the latest to the older. In the very last file where you have worked on, that would be on the top most uh, list, and the others are afterwards. So you can open any of the files over which you want to work, but you have previously worked on in a few last days. So the others are automatically, as they get older and older, they are archived. So you can just open up any of the file directly, instead of using the path to file and open and then reaching to the place where you have saved it. And otherwise, whenever you want to create any new data file, or you are not uh, finding the file over which you want to work in this list, you just cancel it. So it will be moved from the screen. And now we have a blank SPSS sheet in front of us. You see here, its layout is just like Excel. We have different columns here, and above here, this is actually the title bar where you find the name of the variable which are part of your data sheet. And now I open up a data sheet from the SPSS library, because it's very important that everyone should know how to open the file from the library. There are several files lying within the library of SPSS for the tutoring purpose, on which you can work. So once you want to open the library file, you just follow that path, that clicking on the file, and then we have open. So here we have two options, new and open. New is whenever you want to create any new data file, you will select the option of new. But in case you want to open the existing data file which is lying in your system or any destination within your system, you will use the open option. So file, option, and then we have further options according to the type of the file you want to open. If you want to open the file of data type, you will choose the data. In case you want to open the output file, we have the output. And these are two options for the programmers. For example, if you want to write a syntax, program syntax for specific commands, so you need a syntax. So these are usually for the programmers who use not a GUI, graphic user interface, and they just write their own programs, so they use the syntax and the script. But so far as we from the social sciences people, we basically prefer to use the inbuilt or the graphic user tools and techniques which are easily available, and we usually apply these. So only two options we select here, or the data or the output. Depending upon, if you want to open the output file, you use the output, otherwise the data file, we choose the data. So as you click on the data, then you will wait, and then another dialog box appears, and that is obviously to choose the file that you want to open. And now here we have to choose the destination where our library is. So to search the library, first of all you will select the drive where you have installed the SPSS in your systems. And in my system, the SPSS is installed in C. So as I clicked on the C, I have program files here and several files, but you will find the directory of the SPSS in the program files. So I have two types of the program files with me, the program files and program files, and within parentheses, you can see x86 is written. So you will search out where your SPSS is. And in case it depends upon what is your 32-bit or 64-bit Windows installed. So actually, these are the reasons due to which we have two program file folders with us. So in my systems, the IBM folder is lying within the program files cross-86. You see here, as I clicked on the program files cross-86, so I have seen the IBM folder over here, because the IBM is the wholly solely owner of the SPSS. So that's why IBM uh, folder appears. So you just check with your system. You will find your IBM in program file 86 or simply the program files folders, depending upon where your system installed the SPSS directory. So here IBM folder, when I click the IBM, you will see the SPSS. You click on the SPSS, you will see the statistics. If you click on statistics, you will find a folder with the 2020 means the version 20 of the SPSS is installed. In case you install the SPSS 23, you will see the 23 here instead of 20. You just click on 20. So several folders are with us, and now we are interested in samples. So in the samples, you will find the English, but if you install any other version of the SPSS, the several languages will appear, such as Chinese, you see Arabic, the English, French, etc., etc. As you see, we are comfortable with the English. So here, this is a simplified version where only English is appearing. So as you click on the English, so you can see several files in front of us. You see here. So you can select any of the file which you want to open, and let me select this demo. So I'm just choosing the demo, click on the demo, and then open, or either you double click on the demo, it will also open up that data file. So I've selected the demo and then pressing the open. So you see here that data file is in front of us, and several variables are lying here, and the name of each variable is written over here, that is age, marital status, age, income, etc., etc., etc. So here we have all the variables related to this data sheet. And if you want to see that how many the sample size being used here, so you just press this down arrow key, or you just hold this bar and go down. You see, on the left extreme we have cell numbers. You see, in this way the data end up, and we just check the 6400 entries are lying in this data sheet. So one row is representing one respondent. So 6400 individuals were surveyed, and their data are lying in this data sheet. So here we have two views. It's the data view. The data view is the view of the SPSS data sheet where you find all these data values. And if you want to enter the data in the data sheet, you should use the same layout, which is the data view, to enter the data as well. And now we have another view, variable view. If you click on the variable view, so you can switch the views here. So you just click on the button, so you will see the corresponding view. So variable view is the place where you find the name of the variables and all details and the properties of the variable which are part of this data sheet. You see here, some of the characteristics are important, and some of the characteristics are trivial, you see, but I discuss one by one, which are important for your understanding. So here, first of the characteristic related to the variable is a name. So name is actually a brief, you see, briefly we call the variable. So usually these are brief name, as you can see here. These are age, marital address, income category, etc., education, employee. So who created that data file is showing a very good example of selecting a brief name of the variable. And now the next is the type, which type of the variable it can be. So here we have numeric, and as I click on the cell, you will see a blue button. So as you click on the blue button, so the other types of the variables are also here. So that can show that which of the variable type you can select, or the data variable can have. So here all these type of the variables are here. So the numeric is the variable type which we are just discussing, which is the age. So I'm just canceling it. So in case you create any serial number, as I discussed with reference to the questionnaire I shared a few minutes before, so you should select the string here. So you see here string option is given. So you will select the string option. And now one thing which is important with reference to the name of the variable, that what the name can be. So here in the name column, when you select a brief name of a particular variable, you cannot apply the space to separate two words. For example, if you want to select the name as age of person, so here we have three words: age of person. So to separate age of person, you cannot use spaces here, because spaces are not accepted in the name column. The here, the only thing which you can use here to separate the words are the underscore or dot. So you can use a dot or underscore operator to separate the words. But you should prefer that your name must contain no such separations, and only the brief name you should call the variable, and that brief name should be without these special characteristics and spaces, etc. So in case you give a space, it will automatically prompt you that you have selected an illegal character within this uh, column, and it will not accept it. So it will move back to the anything else which is not of your choice. So ultimately you should understand that spaces are not acceptable here, so don't give the spaces. And the numeric, I have explained there, you can select the type of the variable. So here you see the gender, the string, he's choosing the string variable here. And now in the decimals, sorry, in the width is actually your column width. It indicates that how many characters your response can have. So accordingly, it will adjust the width of your uh, data view. You see here, so it will automatically uh, select that. So by default, if you create any data sheet, by default this width is 8. So you can adjust accordingly by selecting the down arrow and the pressing the up arrow key to increase the width of that particular volume. So next of the variable is the decimals. So decimals is actually, sometime we have the decimal in our responses, such as if you mention the salary, that salary is 232.33. So in this way, when your point is, lying within the characteristic, then you should choose the decimals. But otherwise, if you keep the decimal as 0, it means there is no any point inclusion in your characteristic. I just show you that in the data, no decimals are here. But here in the income, you see the 2 decimal points. Income category, we have 2 decimal points. Car value, I think 2 decimal points. In the car categories, we have 2 decimal points. But here there are no decimals. So in case you select the 0, it means there is no decimal in your responses. But in case there is, you can choose the decimals according to the available decimal points. So whenever 0 is there, means no decimal, 2 mean 2 decimals. So that is up to you, depending upon your data. If the decimals are important, you should use the decimals. So here the label column, the next is the label column. Label is actually the brief description about the variable. So that is for the facility of the reader, or the person who is entering the data must know that what is lying within a variable. So here you see age in years, marital status, years at current. So here you can give any of the spaces, special characters. You see, you can include anything here, but you cannot include in names. But in the labels, you can write anything, and that is a brief description about the variables and what the variables is having. And the next is the value. Value is actually very important column where you create the codes. And you see here none means there is no code, because here if you go back to the data view, the ages of the respondents are given, so 40, 41. No categories are lying here. So whenever there is non-categorical questions, it is none. We never provide or assign any of the codes to that. So in your marital status, we have seen here, as I click on the blue button is appearing, you just click on the blue button, you see two categories are with us. 0 is unmarried and 1 is the married. These are single digit code. You can choose any number of your digits for specific codes. It can be 1 digit, it can be 2 digit, it can be, any types of the digits. It depends upon the how many categories are we have for a particular variables. So usually these are single digit, because single digits are easy for us to enter while making the data entry. So here missing means if you want to assign a particular code whenever there is a missing entry. Missing entry mean somebody is not giving you any response for a particular question. So while making the data entry for that particular questionnaire, so you will leave that uh, column or the options or the cell blank. You never write anything there. So that is considered as missing. But in case you want to assign a specific code for that missing value, you just mention over here that whenever the code this will appear, that is considered as missing. So here you see internet, so 8 comma 9 are here mentioned. So it means whenever 8 or 9 is appearing in the data sheet, the SPSS will consider this as missing informations, and it will not include it for the numerical calculations. It will consider it as a missing. So these are the columns. By default it is, 8 columns are selected by default, but you can increase that columns depending upon what sort of length or the width you want to keep for the that particular variables. But this is not of that importance, is trivial ones. So this is something about the alignment of the data, statics of the data sheet. You want to see the left align, right align, etc., etc. So this is actually the measure. So as I mentioned that version 20 just consider the categorical questions and differentiate the ordinal and nominal, but so far as the continuous type questions are concerned, it keeps only one category, that is scale. So it never differentiate the ratio scale and the interval scale. But if you use some advanced versions such as 22, 23, 24 version of the SPSS, it also have two categories under the scale category. So, but keep one thing in mind, that whatever you choose here, SPSS will analyze any type of the measure scale which you assign. It never affects on any of the analysis. For example, if you have a descriptive analysis and scale is written over here, or the ordinal is written over here, or the nominal is selected over here, there is no any difference in your output, whatever you select over here. It is just for your own information to see that what or the which type of this variable is it ordinal, is it nominal, etc. Otherwise it is nothing to do with the output of your SPSS, whatever you select over here. So I usually call it as a trivial information, but the important information that you should know is value and then numeric, name, and label. So these four columns are of more important for you to understand that what these four columns are. Otherwise, all the informations are just trivial. It's not that important. So this is actually the data sheet. I have opened it from the library, and now I open another file which is new. You see here, new. So the data, and why I am opening it, because I want to create a new data sheet in SPSS for the particular questionnaire I discussed. So you should know that how to create a variable in the SPSS and how to save that particular data sheet in the SPSS directory. So I clicked on the data. So you see it has created a entirely blank data sheet. And now I will create the variables for that. So you should go to the variable view. So as you click on the variable view, your blank variable view will be with us. So looking at the questionnaire, you see what is the very first question with us, the serial number. You see, and now I'll create a variable for that serial number. So here SR, and to separate the serial and the number, I am using the underscore and O, so serial number. And as you click anywhere else, the SPSS will set the other properties by default. You see, it has automatically selected numeric, the width is 8, the decimals are 2, the labels, etc., etc., whatever these are. So, and now I will change some of these properties according to my own choice. For example, the numeric, this is not a numeric, the serial number is not numeric. So I will modify it and I'll select here string. So how you can change, I repeat it here, the cell you want to change or the property you want to change here, just click over that place. You will find a blue button. Just click that blue button. So you will find the options you can have and you can choose. So I'm choosing here string. So click on the radio button string here and pressing the OK. It has changed the string. And now the width, just leave the width because the string has no decimals. So automatically it will dull your 0. And the label is a place where you just briefly uh, describe the variable. So this is serial number of the respondent. So I have written here, see I'm giving spaces here and SPSS is having no objection on. So values, no need to give any value, etc., etc. And there is no any change in the other properties. So I have created one of the variables. So the next of the variable here in the questionnaire is age, and we are having 5 categories. The first category is age up to 20, then 21 to 25, 26 to 30, the age of gaps of the 5. And then we have a gap of 10 here, 31 to 40, and then 41 and above. So here you see this is a categorical question. So we should create the categories for that particular variables, if you create in the SPSS interface, you see here is the age. So I'm just naming the variable as age. And as you click on somewhere, automatically the other properties are set by the SPSS. It's a numeric type. We'll keep it as numeric. And so far as the decimals are here, you see, we will enter only 5 codes. It would be 1, can be 2, can be 3, can be 4 or 5. So 1, 2, 3, 4, 5. 5 or only options we can enter here whenever we'll make a data entry. So as you see, there is no decimal in 1, 2, 3, 4, 5. So better is to keep as 0 decimals. So 0 is a decimal, and the label, you just briefly describe the variable, that is age of the respondent, and the value, the most important one. So as you click on the values, the blue button will appear. Just click on, and now you will create the code here. The code can be the same code as you have mentioned in your questionnaire, depending upon, sometime in the options we just give A, B, C, D, etc. So the A, B, C, D cannot be considered as codes while making the data entry. So you will translate A, B, C, D in terms of the numeric value 1, 2, 3, 4. So these can be the same in case you have assigned these categories with the numeric 1, 2, 3, 4 codes. But in case these are ABCD or Roman 1, 2, 3, 4, you should translate into codes 1, 2, 3, 4, 5, etc. So the first code is 1, and that is up to 20. You see, add. Once you create one code, don't forget to press the add button. And now the next code is 2, that was 21 to 25, add. And the 3 is 26 to 30, and the 4 is 31 to 40, and the 5 code is 41 and above. Pressing the add. So I have created all the codes. And once you have created the codes, don't forget to press the OK button. So if you forget to press the OK button, it will not assign codes to this variable, and you will have to create the codes once again. So pressing the OK button, as I press the OK button, it has assigned the codes here, and now in the values column you can see the codes. And now what is something important with these codes? I'm again clicking this blue button, so you will be back to the interface where you have created the codes. And now, for example, if you want to make some changes in, for example, here the code 3 is 26 to 31, not uh, from 26 to 31. So go back to the place where you want to make changes. So just make a changes here. So instead of 30, I'm using 31. So as you slightly change or modify a particular category, the change button will appear. So if you create and you want to create these changes, just press that change button. So as you press the change button, you see here it has changed it according to the modification made by yourself. And one more thing, that for example, I have created a code number 6 by mistake, that which is 45 and above. For example, there is a code And later on, I see that this code I have created here and it's not of any use. So you just select it. So as you select any of the code, see here, a button with us which we can operate is a remove. So you just press the remove button. So you can remove and modify the codes at any point of time, even once you have entered all the data and later on you realize that you should enter one of the code and there is a modification requirement in the codes accordingly. So it will not make change in your data entry. Means I mean to say, if you have entered the code 8 and you are modifying here something, that 8 will remain 8. It will not change. The changes you can made here is the codes. You can change the codes. Otherwise, the data genuinity remain as it is. Whatever the characters you have entered cannot be changed unless you change it yourself. Means you just remove the 8 and instead of 8 you write 6 or 7, whatever. This you can do, but while making the changes in the codes, any of the data entries not change. So whenever you have make the changes in the codes, don't forget to press the OK button. You see. So as you press the OK button, it will uh, select that values codes for that particular question. And the next of the variable was gender. And again, it is numeric. Don't change it. By default, it will select the numeric as numeric. So in the gender, we have two options, the male and the female. So 1 or 2. So there is no decimal in 1 and 2. Again, I am reducing it to 0 and describing the variable, that is gender of respondent, or you can say is a sex of respondent. And in the codes, you should create 1 for the male and 2 is for the female. Adding and then okay. So in this way, you can create all the codes according to the questions. So the next was monthly income. So income only, and it is numeric. And since it's an open question, the scale type of the question, so your respondent can write anything, maybe in the decimal, may not be in the decimals. So we'll keep the 2 decimals here. And that is monthly income. And there is no need to mention codes because these are non-categorical. This is non-categorical question. So you don't need to assign codes, etc., or create the codes. So in this way, one by one, you can um, create different variables and their codes, etc., etc. And now let me show you the complete data file for this particular questionnaire that I have created it before your workshop. So open the data, and now, well, I remember these are lying on your desktop. So selecting desktop, we see here soda survey dot save or soft drink save. So soda survey, so you will select here. So keep in mind that the data file is with the extension of SAV. So whenever the code the extension of the file is SAV, it means this is a data file. And in case it is SPO or SPV, these are output file extensions. But so far as the data file are concerned, the extension is .save. So select here and pressing the OK button, you see here. So I have created here few of the questions, the 7 questions I have created. So let's see what is lying in the other file. Going back to the same place, soft drinks. See here, a complete uh, data sheet is here. So here in this particular data sheet, all the variables are created, and some of the data entries, only one data entry is there for me. For a particular questions, I have made the data entry for one of the question. So this is a data view. Only one respondents responses are entered, and the variable view, here you can see all these variables. So one important thing is that you can use the copy paste option here anywhere within that variable view. For example, if you want to have these codes for any other questions, so you don't need to create these codes again and again and again for several type of the questions, in case you are dealing with the questions and those are having the same codes. For example, just I show you that in this particular question we have Likert scale type of the questions. In the end, you see we have five six questions, and here for all these questions the codes are same. So you should create the codes for any of the question, and then you copy and paste in front of the other questions where the same scales is being used. I just show you here. You see, here the codes are quite similar. So you don't need to create the codes every time. So if you have created one time, you just copy it and fill up the remaining properties of the other variables, and where you want, you just copy and paste it. So copy paste option is workable here, but I have seen in some previous versions such as SPSS 16 or SPSS 15, this option was not workable, that you cannot use a copy and paste. But now the SPSS is providing us the facility to copy and paste options are applicable. So that is something to create a variable. And now the last we want, with reference to this created data sheet, that how you can save it and how you can reopen it. So here, once you have done with this, you have created, for example, all the questions, and you want to save it for your future use and for the data entry purpose, you just click on the file and save as. As you press the save as button, it will uh, just allow you to select the destination where you want to save it. And for example, if I want to save it over the desktop, so by the down arrow you can choose any of the destination where you want to save that particular data sheet. But for example, I want to save it over the desktop, so I'll select the desktop, and now here the file name, so I just name it by workshop workshop data, your workshop sheet, you can say. So as you give a name, just press the save button. As you press the save button, uh, you see this floppy sign get dull, and now you just, for example, I want to close it, so just press the cross, and now again press the cross, and it will ask you whether you want to save the changes made in that data sheet. So I haven't made any changes, so pressing the no, and similarly, and it's in the last asking whether you want to close that SPSS, pressing the yes and saving the output. This is actually the output of your SPSS, and in the output you see all these executions that you have made, or whatever the algorithms are for the particularly done work. These are lying in your output of the SPSS, and the output file is saved separately. So as you see here, nothing is on your output, and you want to remove that, you're not willing to save that, you just press that cross button, save the content. So I don't want to save it, so no. So again, back to the data sheet, pressing the yes, I want to close it. So you see the SPSS is totally disappeared, and now I'll show you how you can reopen that data sheet which I have just stored with the name of workshop sheet. So again, I will open the SPSS. This is the icon of the SPSS. You see here, again SPSS is opened, and that workshop sheet is lying here, the name, because I previously worked on it. And before that I worked on the soft drink dot save. Before that the soda dot survey was in use, and then I opened the library file of the demo. You see here, the ranking is lying so far as I worked on these data files, and according to the ranking of the use and the the times I use that data is, ranked in this list. So you want to open the workshop data, you just select it, it's already selected, and pressing the OK button, you can open that data sheet. And for example, you just forget that where you can open that data sheet. I see, I show you another place where you find the name of the file you have worked on previously. You just click on the file, recently used data. So here you will see the data file, and down there we have output files. You see here the SPV is the extension of the output files. So recently used data. So these are ranking wise 1, 2, 3, 4, 5, 6, 7. So for example, I want to open the soft drink. So you see, you just choose it and it has opened that particular. So there are several places you can open up. And now, for example, I forget all these shortcut paths where I can open the data files. Then what is the manual way of opening any of the file? That is just click on the file and make a choice. You want to open any existing data file or the output file. File and open and data, and just assign the place or the destination where that file is lying. Suppose it's lying on the desktop, and that file is the soda survey. Just select here and open it. So this was something to create a data sheet in the SPSS. And now I will just take a break of few minutes, 5 minutes for some water intake, etc. So meanwhile, you just write up the questions which you have in your mind regarding the creation of the data sheet in the SPSS interface, or the questions, question types, the codes, etc., etc. You just write the questions on your notepads, and after the 5 minutes, I meet you once again to discuss all these questions. So I'll be back after 5 minutes. At the moment, I have the time 11:17. So exactly after the 5 minutes, 11:22 or 11:23, I'll be back. We are back again, dear participants, and just mention your queries in the chat box, and I just read them and address one by one, and possibly I answer the all. So can we move ahead in case there is no question?
So there is one question. Can we change Excel data sheet into SPSS data sheet?
The same point I'm discussing next. Once I'll open the data which I have provided to all of you, that is already in the form of Excel sheet. So we'll learn here how to open the Excel data sheet in the SPSS sheet. So I think that would be addressed later on. So if there is nothing else other than this query. Oh, now I discussed the framework. That is the next agenda item with us. So can you see this framework? I think it is shared already. Jawad, can you see this framework?
Yes, sir, I can.
Okay. So actually, this is a framework of the research. The data of that research is already with you in Excel sheet, and we will apply different techniques and tools for this data sheet. And for that particular data sheet, let me reduce the size so that complete structure we can see here on the screen. So here, usually in the social sciences, we are doing the researches exploratory or confirmatory. So whatever, whether these are confirmatory or exploratory searches, we are dealing with the different structures and such type of the variables come across. Actually, this data is related to teaching institutions, and this research is related to HR. Again, the HR is a field of social sciences or the management sciences, you can say. So here we have few of the variables. These variables are mentioned here on the left hand side of that research framework. All these are independent variables, and the dependent variable is here. So the dependent variable is the job satisfaction, and the job satisfaction they are measuring through a construct, and within this construct we have 5 questions, and in the terminology of the analysis we call these questions as items, and this variable is known as construct. So the job satisfaction is a construct, the university vision is a construct, the teamwork is a construct, the quality and internal customer is a construct, employee is a construct, benefit is a construct, and training and development is a construct. So how you can identify a construct? So in case there is one question, for example, there's only one question such as I have real opportunities for career development in the university. So this cannot be called as a construct because only one question is for that is being asked in the questionnaire. The construct means it contain several items, and these items collectively or jointly will address a single phenomena. Then this would be called a construct. And broadly, this is also known as a variable. So job satisfaction is a variable. And for this particular variable, we are asking 5 different questions from the respondent. And collectively, these 5 questions should give us a direction towards job satisfactions. That's how these constructs are built, and their reliability is tested. And the purpose of testing that reliability is whether all these 5 items addressing a single phenomena, and there's a specific threshold through which comes we come to know that these items are addressing a single phenomena or not. We'll discuss in some little applications or the method we are going to apply. So here this research framework is made, and whenever you perform any research containing the independent variables and the dependent variables, you must prepare such type of the structure so that it is easy for you to understand that which type of the relations you want to see and you want to determine in your research. And here in this framework, you want to see that whether the university vision, if a university vision uh, can predict or can impact on the job satisfaction, can the teamwork can impact the job satisfaction, and separately all these independent variable one by one can raise or decrease the job satisfactions, or collectively when these all independent variables are present at a time, they collectively can create a job satisfaction or can have an impact on the job satisfaction. That is basically a exploratory research. We'll explore, and this is correlational or the regression type of the research we can have here. And usually these type of the research I have seen the students are doing in file in SPSS interface. So you will learn how to open an Excel file in SPSS. So meanwhile, to discuss or this framework, if you have any question regarding this framework, please do ask and don't hesitate to ask any of the even minor question you have in your mind. So hurry up, please. Oh, sorry. I've explained a lot of detail, but unfortunately, I don't know. My microphone was turned off. So I answered all the questions. So very sorry. I was there and I was answering all the questions, but the microphone was off. So
Uh,
anyhow,
it's okay. We all are waiting for you. We thought you have taken some break.
no, no, no. Actually, I was speaking up unaware of that my microphone was off. So I explain once again.
Yes, please.
So
Thank
the
you, sir.
okay. So the question was, is construct necessary? But by Asad and Ishanze. Actually, sometime the questions collectively or jointly address a single phenomena. For example, if you ask someone whether you are happy with your job or not, so I will straight away say that I'm happy or I'm not happy or moderate, so that is not a very crystal clear answer to the job satisfactions, because the job satisfaction is made up through different tendencies, such as the infrastructure which the employer had provided you, or the fringe benefits your employer is giving you, the salary structure of the organization, and the organizational culture, and so many such factors which are jointly addressing the job satisfaction. So it would be not fair or accurately measurable if you ask one question to the respondent whether you are satisfied or not satisfied. So to measure it accurately, the researcher do, they build up a construct, and this construct contains several questions, and these questions are part to part asked from the respondent. For example, you see here, if you look at the dependent variable, the job satisfaction, the first item is I have real opportunity for the career development. I am committed to my career in the university. I feel that university has caring attitude toward the employee. I feel that get already predominatory. So it's autonomy related something. I would recommend this university as a place to work. So all these five items are addressing different things. And the researcher believe that if the respondent is happy with all these component to component, then collectively these questions will address a single phenomena, which is the job satisfaction. And sometimes the people hesitate to respond directly for any question, so cleverly the researcher asks different small petty questions, and through which they extract an important factor, and which are collectively constructed through several items, and this collection of the items is known as a construct. And it is important and very easy to measure the phenomena. And whenever you are measuring something through the construct, and which are containing several items, and if any respondent is deliberately want to hide, or do not want to share something directly and hesitate to say something, if you ask several petty questions, it is very hard for him to hide something from these several questions. And to some of the questions he will be forced to respond in an accurate and correct way. So if he is trying to hide something, you can uh, have the answer of that question through asking several small questions. So that's why the construct is important. But sometimes the construct is not important, such as if you are interested to know what is your gender, whether you are male or female, so it would be is an idiotic way if you develop a construct just to know only what is the gender, whether somebody is a male or female, because it can be asked through one single item, so you don't need a construct over here. But sometimes some typical and the complex question is, the objective of the researcher, and that is not possible to ask through one single question. So you just build up a construct that contains several items, and these items collectively address a single phenomena. So I think now you understand why the constructs are important for a particular research. And now the next question was by Danish Zahra, that what is the dependent variable and data is unstable, will it affect all independent variables? Actually, the correlation in the correlational research, we determine this thing whether these independent variables are impacting on a dependent variable or not, because dependent variable is something which is directly is in not your control, because the job satisfaction is not directly in the control of an employer is something just such as FC College is an employer. You see, the Pepsi Cola is an employer, Coca-Cola is an employer, or the Nestle milk pack is an employer, or the Hire is an employer. An employee are the people who are on their job. So the hire directly cannot control the job satisfaction of the employee, because the job retention or employee retention is the main issue which is faced by the employer, that they want that if somebody is working in any organization, must stay in the organization for the long time, so that the employer can have the benefit of the experience of such employee. So directly it cannot be controlled by the employer. So always they look at what are the factors which can increase the job satisfaction of the employee. So because these factors are in their control, such as university vision, the teamwork, the quality, internal customer, the employee benefits, the training and development, these are something which are in control of the employer. And if they work on these things, and these are if really impacting on the job satisfaction, then they will work on. And when they work positively on this, the job satisfaction is automatically raised within their employee, and they stay for the long time in the organizations. So the purpose of such researches is which are known as correlational or the regression type of the researches. The objective is to see whether the independent variable are impacting on or have an effect on the dependent variable or not. So that is basically a research questions. So any other question? I resume back participants. I just changed my place.
Okay, well, if you have any more question, please do ask.
So we can proceed as we have no other questions.
Okay.
So now I just open up the data file on Excel, and we discuss something about the data given in that. So can you hear me clearly? Is there any echo or something else?
So
Is
we
it
can hear
clear?
you clearly.
Okay, okay, good. So let us share. Is this Excel interface is visible to all?
Yes, sir, it's visible.
Yes, sir.
Okay. So going back to the framework. So you see here, uh, in the dependent variable, all these items are with the questions, and their brief name is A1, A2, A3, A4, A5. Then the letter B is for the university vision. Then C is for the teamwork, and D is for the quality and internal customer. E is for the employee, F is for the benefits, and G is for the training and development. And you see 5 of the items are for the job satisfaction, and 4 items are for university vision, 2 items are for teamwork, 7 items are for the quality and internal customer, 5 items are for the employee, 3 items for the benefit, and 2 items for the training and development. So going back to the Excel, you see here these A1, A2, A3, A4, A5, and B1, B2, all these are the same as mentioned in your framework, and all these questions are addressing the items pertaining to the construct. And now, so far as the variable view, the code sheets is in the variable view here. So you see here, the first is the ID, identification, uh, the respondents of the university, and the universities are, you see here, you just we just clear it that what these are. So these are the university respondents from the UET, Punjab University, and LUMS. And then we have group of the employees, academics and the non-academics people. The academic people are who are just professors, these are teaching, and non-academics are the administrative staff such as accounts, the the registration people, the other administrative staff, these are also part of non-academics. And then we have so these two are the demographic variables, and so far as the other are concerned, these are continuous variable in the constructs. And one should be very clear to all of you that whenever you construct, you develop any construct and the items lying in there, they must be measured on a similar scale. For example, you see all these are on a similar Likert scale. So in case that scale is disturbed, for three items we have different scale, and for the two items we have different scale, this cannot shapen up a construct and we cannot call it as a construct. This would be a construct if the all items are measured on the similar scale, and the legends of scale should be quite similar to each other. Maybe some reverse codes are used deliberately by the researcher. They deliberately change the codes in a reverse order to cheat the respondent, or just to you see the looking at the readability and understanding of the respondent, they deliberately change the code in the reverse order for some of the questions, but the scale is usually the same. In case the scale is disturbed, then this cannot be called as a construct. So keep in mind always while developing any construct that all the items or the questions which are lying in any construct, they should be uniformly on a similar scale. And now here you see the labels mean these are different questions. These are same questions as mentioned in your research framework. These are all numeric types. The two demographic variables are in the research, and all these items are particularly for the construct mentioned in your framework. And now here, one thing uh, that should be in your mind, that code 1 is for the strongly agree, 2 is agree, 3 is neutral point, and then similarly um, next code would be 4. You see, that is for the disagree, and 5 is strongly disagree. So usually it is in reversed order. Mean actually the Likert scale, when it starts, it should start with the least value of the code should be will strongly disagree, and then 2 is for the disagree, 3 is the neutral point, 4 is agree, and 5 is the strongly agree. This should be the codes, because once we calculate their average and we understand as the average score is increasing, the agreement of the respondent is increasing. But here it is in reversed order, that as you see the result is increasing, the tendency behind that increase is the dissatisfaction instead of the agreement. So we should first of all reverse all these codes in the entire data sheet. And this mistake has been deliberately made in the data so that another technique you all should learn, that how to reverse the codes in case the codes are recorded in unacceptable order. And now you see how you can open that data sheet in your SPSS when actually the data is entered in Excel interface. So I close this file, and before closing that file, you should all know that in which of the sheet that data are lying. The first sheet is a variable view, whereas the second sheet is your data view. So I am closing this Excel. You see here, don't save. See, okay. And now in the in the SPSS, how we can open. So first I open a new file, new data, or you can say then data. If you want to create a new data sheet, then you should take the new data. Otherwise, as we are opening the existing data file, so I'm using the open option instead of new. So data, so where this data are lying, the data is on the desktop, and the folder is the PRC workshop where it's lying. And now here you should change the type of the file, and here you see the save file, but our data is in Excel. So you just this down arrow key, so you will find the Excel. You select here Excel. As you select the Excel, you will see all the Excel files in your folder which you have selected over here. So the SPSS code book is the file name, so I will select it and press the open button. So as you press the open button, another window or the dialog box will appear, and that will ask you which of the sheet you want to open. Since there were two sheets, one was the variable view and the other was the data view. Here, by pressing this down arrow key, you will see all these data sheets in this Excel file. So we are interested to open the data view. So I have selected the data view, and once the appropriate sheet is selected, so you will press the OK button. So as I press the OK button, so you see it has opened up that particular file, and this is your data, sorry, variable view, where you can see all these variables which were in your Excel file. And this is the data view. So again, you can see all the data and the title bar containing the same name of the variable which are mentioned in your Excel file, and the same entries are lying over here, whatever these are in your data. But here, if you see the variable view, the no any information related to the values are mentioned. So we just try to copy and paste it from your Excel sheet. And otherwise, if you want to enter manually all these things, you can manually enter. And one more thing, that measures in all these, you see, against all these variables, it is considering at a nominal, but this is not nominal. In the first, these are ID1, mean the university names. This is nominal because it contain only the names of the universities. The other is A1. No, it's not giving any questions. So one by one, you will go to every question and you will change the property of that. You see, I have made the modifications in all, and now let us save it. So pressing this floppy symbol, or otherwise you can do it like file and save as. The save as. So in the save as the same folder, we choose the PRC workshop, and I give the name to workshop data, and then pressing the save button so that it can keep all these changes which I have made. And now let us make the other changes. For that, I need to open the Excel file once again. And I copy few things from the variable view. So you see here the codes I need. So it will not, I think, select the codes types. So let us try if it accepts. So copy and going back to the workshop data. So just no, it's not accepting. So we should give it or assign the values manually. So first of all, we look what it, one is UET, the second is Punjab University, and third is LUMS. So accordingly, we'll create a code here. The first is UET, add two was PU, and the third was LUMS, adding. So as I have created all the codes, pressing the OK button, and the code for this, the one is academic staff, academic, and the two was non-academic. Non-academics. So adding and pressing the OK button. And now the next is the codes for these items. And now we will develop all these codes as per the traditional way, that usually the one is strongly disagree, strongly disagree. The two is the disagree code. Third is your neutral point, neither agree nor disagree. Number four is agree. And five is strongly agree. So I now just copy this, because within the SPSS sheet, we can use the copy and paste for the values. Copy, and now I select all at once together and paste them. You see, it has copy and paste works, and the all codes are defined. And now going back to the Excel sheet to just have the title of the variables, the labels. So this will, I think, work, because there is no technicality involved in the names. So copy here and going back to so here paste. You see all these labels are with us. We have pasted it. So the copy paste works here. And again, we save this data sheet so that the modification further should be saved. And so far as the column width, these are 11, so we don't have any objection for that. And now one thing, there is a mistake, and that mistake is that these are reverse codes. So how you have to reverse these codes? So for that, see very carefully that how you need to code reverse. And now you go in the data. Uh, so the transform will be using now the transform options. And the transform option is, you see here, record into the same variables and record into the different variables. These are the two options. By using these two options, we can change the codes or the reverse the codes into our desired changed codes. If you use the record into the same variable, the SPSS will make modification within the same variable. And if you want to keep the original data as it is, and you want to create the same set of variables with the reverse code, then you should use this record into the different variables. But since we want to make the modification within the same variables which are lying in this data sheet, I just select the record into the same variable. And now whenever you just press this options, here we have the variables listed for which you want to make the changes. So I just select all these variables, leaving the first two. Select all and shift them here. Because we want to make the modification in these variables, and these variables we do not want to modify with the code changing. And now here, as I have selected some of the variables here, this button is glowing, that is indicating the old and the new values. So you just press this one. And now as you press this one, the dialog box is appearing to show the old values and the new values which you want. So the old value 1, we want to reverse this, or old value 1 to the 5. 1 is to be changed to the 5. Then add here. Then the 2 is to be changed to 4. And 3 will remain as it is. So 3 is to be 3. And the 4 is changed to 2. And 5 is to be changed to 1. So this changes, I am these changes I am making here just to reverse the codes, because in the original data, the 1 is showing strongly agree, whereas in the traditional scale, the 1 should be strongly disagree, and 5 is actually the strongly agree. So here you see here 111, 111 are indicating strongly agree, but these should be actually 5. So that's why I I am making these changes to reverse the codes. So as you see, I have almost translated all the codes to the new codes here. And now just press the button of continuing. So as you press the button to continue, you'll be back on the earlier dialog box, and now just press the OK button. So you will see an algorithm on the output window. So it says that the recode all these codes. 1 is changed to 5, 2 is to 4, 3 is to 3, 4 into 4 is to 2, and 5 is to 1. And then it's execute. So from that output sheet, you can go back to your data view. And for that, you have an icon here, which is a data sheet. And over that, we have a star. So you just press it, this one. You see here, as you press this one. So we are back on your data sheet. And you see previously all these codes were showing 111, and these are now reversed to 555, etc. And wherever there would be 2, 3, etc., you will certainly find certain changes here. You see 2 is also here, 3 is also here. So that's how. So once we have done with the reverse codes, then you should press the button of the saving so that the changes remain saved. So let me check with this chat. So I think all these questions are already addressed. And if something new want to ask, you just mention here. And now see, I just introduce you another button that would be very helpful for you to understand and translate back the code or swipe back the code to the category. And that is this one, 1 and A. 1 and A actually is a button that translate the code to the category written behind that code. So as I press this button, you see here, the wherever the code 1 is there, for that ID 1, the UET is appearing. And in the second, the code are reversed to the academic or non-academic, whatever the category and the code are. These are swiped back, and the strongly agree is in front of you. And similarly, agree is also neutral, some points with a strongly disagree, etc., etc. So all these codes are now reversed or the swiped with the category behind that code. So at any point of time, you can check by pressing this button to see that if the code is appearing, to know that what is the category behind that code. So you can click here. But mainly we use that numeric interface where these numerics are appearing in front of us instead of these categories written in your Word document. And now once we have managed the data sheet, or the data sheet is in the format where you can perform the further analysis of your research. And now the first objective, whenever your data sheet is exactly ready for the analysis, is the descriptive analysis. And within the umbrella of the descriptive analysis, we are interested to see the frequencies and some basic charts, such as your bar charts or pie charts, to see the frequency of the categories. And now I just show you that how you can have the frequency of the variable and the graph appropriately what you can draw. And now for that, press the analyze, and then we have descriptive analysis, and within the descriptive analysis we have an option of the frequency. Once you click on the frequency, and now we have this dialog box that will allow you to select the variable for which you want to have the frequencies. And now, for instance, I just select 2, 3 variables over here, but let me clear that altogether you can select all the variables at once. And now here you have a checkbox, and that checkbox will display in the output the frequency table. And if you uncheck this, the frequency table will not appear in the output. So I have selected this checkbox, and now here the chart you want. So for example, if you want a bar chart, I have selected the bar chart. If the none is selection, no chart will appear in the output. But if you select any of the chart, you will see that appropriate chart in the output. And the bar chart here I have chosen. So whenever you choose the bar chart, you should select the percentages, because it give you better understanding and the interpretations if you select the percentage. And pressing the continue button, so you will be back on the earlier dialog box, and then just press the OK button to see what we have in the output. So it's processing. So as you see, I have chosen only 5 variables for that particular analysis. So it will begin with the frequency tables. These are frequency table for the first variable. This is for the second. This is for the third. And this is afterwards the variables selected, so forth. And now discussing the first table. This is actually indicating that how many data values are with us. So it indicates that 1014 entries are in our data sheet, and there is nothing information as missing. The 0 information is missing. In case something is missing information available within these data, it will indicate that these are a few of the entries which are indicating missing informations. And now the next frequency table. This is for the first question, which is respondents of the university. So you see here, 3 universities are in considerations where the data were collected. 264 respondents are from UET, 550 from PU, 200 from LUMS. And here you see the more respondents are from the Punjab University. That is because of the volume of the Punjab University you see is a very big university as compared to the others. So that's why the respondents are more here, and might possible that the person who has performed research or collected the information belongs to Punjab University. That's why the number is more here. So far as if you translate them in terms of the percentage, 26% are from UET, 54% from PU, and 19% or the approximately 18% from LUMS. So valid percentage, actually valid percentage and percentage are same here, but these cannot be same in case some of the information in our data sheet are missing. Then actually it uh, create a difference in the valid percentage and the percentages. So cumulative percentage is your step-by-step addition of the percentage. For example, the first is carried forward as it is. And if you add 26 to 54.2, then these total collectively means, if you look at the total respondents in the first 2 universities, so 80.3% of your respondents are belonging to the first two universities. And this is step by step sum of all these percentages, which is cumulative percentage. And now we have another table for the academic and non-academic variable. So it's very clear that non-academic are 65.6%, where 34% are only from the academic side. And similarly, the frequency table for the variable is strongly disagree and etc. etc., which is A1. This variable was A1, the first item of your dependent variable. And that question was, I have real opportunity for the career development in the university. So here you see most of the respondents are in the agree and strongly agree categories, and their percentages are also given in your third and fourth columns. And these are the cumulative percentage. So if you look at up to the neutral, so up to the neutral category, we have collectively 21% of the respondents are falling in these two categories, in three categories, just strongly disagree, disagree, and neutral. And you can realize that if the 21% are covering only the disagree side, it means that 79% of your respondents are agree and strongly agree sided. Sorry for this question. And similarly, you can understand the percentage, and the same thing you mentioned in your write-up. Once you interpret this table, that towards the disagreement and the neutral point, only 21% respondents are falling, whereas 79% of the respondents are covering the agree and strongly agree side. So you can say the most of the respondents are agree with the statement that says that the university is providing them the career development opportunity. So similarly, you can interpret all other questions. You can see here their frequency tables are also given. And now here we have charts with us. So here you can see the charts, and on the y-axis we have percentages, and this is for the respondents of the university. This is for academic and non-academic staff, and these are, agree, strongly agree, etc., etc. And you can see their percentages as well. So similarly, we have all these bar charts, and we can have the pie charts as well. So how we can draw the pie charts for them? And for that pie charts, you can use this button that recall the previously used commands. As you see, as I have moved on through my cursor, so it is saying that recall recently used dialogues. So whenever you are interested to apply any of the command which you have recently applied, you just press it, and you see all these commands which I have used previously are listed here, and the very last is very first here. So frequency, you just press, so you will be back on the dialog box where we have selected the variable for the frequency calculations. And now I don't need the frequency table for these variables, but I need the charts only. So for the charts, and I'm switching to the pie charts, and now continuing and uncheck that checkbox, because if you remain this checkbox as checked, once again we'll have the frequency tables. And since we have already obtained the frequency table, there is no need to reconstruct these tables. So uncheck it and pressing OK button. So I have see these are the pie charts with us. So the respondent university, and these are the pie charts with us. So I personally never like pie chart for the analysis, and in the management level, these are not appreciated in the reports, just because sometime we have more than 5 categories in your question. So this chart never provide you any suitable interpretations. Rather, it just display a beautiful flower displaying different colors, but no any useful information is available in case there are more categories. So that's why this chart is not appreciated in the reports. But so far as the bar chart is concerned, you see here, there is a very clear comparison through the raised spikes to identify that which of the spike is having the most frequent, and it's very easy. And in case the 10 or 20 bars in front of us, you can pick up one of the spike which is highest one. It's very easy to pick up. But in case there are 10 categories in your pie chart, it is very hard for us to rank which of the sector is having most frequent area. So that's why these pie charts are not appreciated in the management sciences or the reports. But it's up to you. I'm not restricting you to not to apply it. It's your own choice, what you like. And now slightly going ahead, uh, to check the reliability, whether these constructs are reliable one or not. As I mentioned earlier, that when the constructs are constructed, it is very important to know that whether all items within the same construct are addressing a single phenomena properly or not. For that purpose, we have item analysis in SPSS. And for the item analysis, we calculate the Cronbach alpha value. And that value, the minimum threshold is 0.70. And if the Cronbach value is 0.70, it means that construct is represented effectively, and the measurement you made through that construct would be effective to address the single variable for that construct. And then going back to the constructs and the framework. So first of all, you see that how many items are for the job satisfaction. So A1, A2, A3, A4, and A5. So these are the 5 items. And now going back to the data sheet. So here we have a data sheet, and these are A1, A2, A3, and A5. And now we select them for the Cronbach alpha. For that, you just carefully look at the place in the analyze to see that in the analyze we have scale, and in the scale we have reliability analysis. You just click on the reliability analysis, and now you want to measure the mm, reliability of the first construct, that is job satisfactions. So as you just move your pointer over the item, question statement ends, within bracket you will see the small name which is A1. So 5 items we will select here. See here, these are 5 items, and as I move my pointer to the last one, it is showing you A5. It means these are the 5 items which are corresponding to the construct which is job satisfaction. Select here. So once you select here, few more things we are interested in, and then we just click on the statistics. And this in the statistics, it is very important to click on the scale if item deleted and the inter item correlations, you see. So these two things you should calculate always to see the details of the construct. So continuing and then pressing the OK button. So you see here, as I have clicked the OK button, in this first table, it will show you the total entries, total the data values. And the next, the table is the most important one, that is indicating you the Cronbach value. And this the first column is of your interest, and this value is 0.984. And as I mentioned earlier, that minimum, the least value you should have for the construct is 0.70. So we have value 0.984. So it means we are far safe and we are quite strong enough to measure the single phenomena through these 5 items, because here the items are mentioned which are building up that construct. So we are quite safe in measuring, and this construct is representing very strongly the phenomena that we are interested to measure. And now the next matrix is actually indicating that what the changes will made in case that item is removed from that construct. So here the item to item analysis is provided to you. This is the first item, the second, third, fourth, and the fifth. It says that if you remove this first item from the construct, then your Cronbach value mm, will what happened to that, and that is showing over here the inter total item total statistics. So if you remove the first item, your Cronbach value would be 0.98. If you remove the second one, your Cronbach value would be 0.98. So in this way, it is indicating that if a certain item is removed from the construct, then what would impact our value of the Cronbach. So since our Cronbach value is very strong enough, we don't need to remove any of the item from that construct. But sometime it happens that some items are correlating negatively with other items, and it has a very pulled back impact on your Cronbach value, and it weakens your Cronbach value. And if you remove that item from the analysis, your Cronbach value gets stronger. So we do sometime such tactics, and we remove such items from the construct. But these all tactics are performed while pilot analysis. We perform the pilot analysis of our data, but we are not doing any pilot study at the moment. Pilot study is done for the experimental purpose to see the validation of your questionnaire, that whether your questionnaire is understandable to the respondent, the respondents are easily understanding each and everything, and they are understanding in the same way as you are asking them. So to determine all these factors, we perform the pilot study, and while making the pilot study, we have a room to modify the question, to change the question, to exclude some of the questions, to include any of the question in your study. So these type of the options we have while doing the pilot study. But once the pilot study is over, then we have no chance to modify our research, because then we go with the objective of collection of the data, and then we collect the data. Once the data are collected, then you cannot modify anything or any questionnaire. So these steps are done before your final data collection procedure. And now here the second table, that is inter-item correlation, actually it indicates that how the item to item are correlating with each other. So it means that first item, this is A1, and A1 is correlating with A2 with a 0.93, with A3 is a 0.93, the A4 also 0.93, and with the last A5 is 0.91. So this is indicating the correlation of one question with the other. So you can see that the question number one is strongly correlating with the other. because the correlation maximum value is 1. And if it is positive, it means that item is positively correlating. Positively correlating mean that that means that if that question's responses are increasing, the others questions responses are also are in the trend of increasing. But in case this is negative, it means the one variable is showing increase and the other is indicating decrease. And if the relation is strong, that coefficient is strong enough, so it is showing you a very strong correlation, so it's not at all weak. So as you see here, in almost in the entire table, except this diagonal, because these diagonal are indicating 1 1 1, because once an item is correlating with the same item, that correlation is always 1. So we should not study this diagonal values, but the upper diagonal or the lower diagonal, you can see the correlation in between the two questions. And how you come to know, for example, you move to any of the value, for example this is 0.948, and you want to know that which are the questions uh, about which this correlation is lying in the table. So you go across to the column. So if you move across to the column, we have the variable I feel people get. So this is a A4 question. And if you go across the row, this is A3. So question number A3 and A4 are correlating positively with each other, and the correlation is very strong, and that strong correlation is 0.948. So it's a very strong correlation. So we realize within this construct that all these items are very strongly correlating with each other. That's why this construct is indicating a strong relation between the items, and this Cronbach value is also very strong. And now one by one, we'll be calculating the Cronbach alpha values for all these constructs. And as I have explained, the correlation matrix for the construct number, job satisfaction, and the item if deleted within the constructs, I will not explain for the other constructs due to the time constraints. So I will just measure the Cronbach value for the other constructs. And now we go back to measure the reliability of the second construct. And then for the second construct, we transfer these values or these variables back to the data sheet. And next construct were with the subscript or the short name as B. So B is because if we get all these checkbox checked, we'll have two tables, which is intra-item correlations and the items. Cronbach alpha is the deleted. So as I have explained it for the first construct, so I'll not calculate them, but you do calculate whenever you are performing your researches to see the all background and the strengths of our constructs. So continuing here, and now pressing the OK button. So as I press the OK button, you see here that construct is also very strong, and which is 0.986, which is far greater than 0.70. So it is also a reliable construct and reliably measure the phenomena that you want to measure through these four items. And these were just look at what it is. It is university vision. So university vision can be measured through these four items very effectively because of the very strong Cronbach value. And now move back to the data sheet for the next construct, and which are C1, C2, the teamwork. So go back to the data sheet and then reliability, and we see send back these items. And what the next we have here, we have C1, C2. So the two items we have. So select two items and then press the OK button. As you see, these two items are also measuring the Cronbach value 0.972. It's again very strong. And once again for the next construct, and that is with the D names, and the D here, the D1, D2, D3, D4, D5, D6, D7, D8. So 1, 2, 3, 4, 5, 6, 7, 8. D9 is also here, and D10 is also here, and next is E. So 10 items we'll be selecting, and now pressing the OK button. You see here again we have 0.993, and this construct is D, is the university equality and internal customer. So here only 7 items are mentioned, but actually in the data sheet we have 10 items for that quality and internal customer. Why it's possible that for the convenience the researcher has eliminated or excluded the last 3 questions from the analysis, because these are lying, they are not lying in your framework, but actually these are part of your data sheet. So look at your output. So we have very strong Cronbach alpha value, which is 0.993, very strong. So moving to the next, first we send all these items back to the available variables, and the next construct is beginning with the subscript, the letter E. So E1, E2, E3, E4, E5, E6, and let us see a few more. E7, E8, so reduce one. So these are up to E8, and now run. Okay, so it's 0.989. Again, we have very strong value of Cronbach alpha. So it's also a very reliable construct. Then I think the last one is left now. So with F1, F2, F3. So 3 items for the F. Next is the G1. So 3 items for the F, and 0.977 is also very strong. Go ahead. So taking these two and pressing the OK, you see 0.90. So you see here all these constructs are very strongly represented through the items selected appropriately for these constructs. So if you have question regarding the reliability, you are most welcome to ask or mention in the chat box, because at 1 o'clock we are going to have a break for 20 minutes for your lunch, etc. So I'm just reading your chat box and switching off mic. So we have a question from Shanze and Asad. So Shanze is asking, what does it mean if there is negative correlation in the data? So negative correlation means that question is negatively correlating with the other questions. And if it is correlating with the more items, means not with one question it is negatively correlated, but more than one question it is correlating negatively, it means it is weakening your constructs. Sometimes it happens that the researcher deliberately reverse the code of the question to check the alert of the respondent, that whether it's the reading the question and then giving responses, or blindly these are signing to agree, disagree, etc., etc. So just to check, some of the codes are deliberately reversed. So in if this is the case with that question, you first of all, while calculating the reliability analysis, you should reverse the code of that question, and then you should measure the reliability. Then ultimately all these negative are turns to positive. And if there is no such anything that the code need to be reversed and question is not asked in the reverse order, and actually that question is creating a negative correlation, it means you should review the statement of that question, whether the statement is in the way that all the respondents are easily understanding what you are asking in the question, and is it easily understandable to the respondent. If it not so, that you should rephrase that question, and then you should amend your construct accordingly. And if you are unable to rephrase it and all the way you see that whatever the tactics you use, it will always create a negative correlation, then it's better to exclude that question from the construct, because it will weak your Cronbach value and the reliability. So this we actually do in the pilot, and once the pilot is over, then you cannot do any of the changes like this. And now the Asad is asking that we can add drop question in the pilot study. If so, then mm, if some of the correlation is weak, which is making construct reliability weak, then can we do? Yes, of course. If your reliability is getting weak by including any of the items, and your table, as I show you this one, item total statistics. So here you will see that if any of the item is correlating negatively, you will find that if you delete that item from the construct, your Cronbach value will increase. So it's better on the safe side to exclude such variable from the construct, or redesign it, or you may include any other question other than that question, which is weakening your reliability analysis. So you are always better to include the questions which are strengthening your construct's reliability, and exclude the questions which are weakening it. I hope I have answered, but you're most welcome to ask anything more. So if there is no question, then we can have a 20 minutes break now. So who is the moderator or controlling that? I would request to pause that recording unless we resume back on. So I just switch my mic off.
Thank you, sir. We'll have a 20 minutes break and we'll come back at 1:20.
So we have so far measured the reliability, and now I want just to review back the agenda to see what we have completed so far and what is left. So this is agenda. Let me open. So this is the agenda. So identification of the variable and its type, creating data sheet and SPSS coding, and creating data sheets. So we have completed. Introduction to the basic graphical charts, pie chart, bar chart, we have completed. Data entry demonstration, I think to some extent we have completed, because many of you are aware that how you can enter the data. So it will take an extra time, and that is not that technical. So I believe it's completed. So basic descriptive analysis of extreme, this is left. And so far as the after the break session, the main thing is testing the reliability of the study instrument and calculating scores. So score calculation is left, but the reliability we have tested, and the scores and the basic descriptive we just perform now. So the descriptive statistics of the data. So these three parts, the understanding of the framework of the study is also done. So we are jointly discussing now descriptive statistics and then calculating score and the basic descriptive analysis of the extreme data, etc. So let's go ahead with that. So once your reliability is tested and we find that our all constructs are reliably measuring the main phenomena and the single phenomena for which the construct has been developed. Afterwards, we have the objective of the descriptive analysis of the each and every question to question, that we include in your descriptive analysis. We complete the calculation chapter of our thesis or the project or the report. So one thing always keep in mind that the Likert scale data is never distributed normally. It cannot be normally distributed. So don't expect that your Likert scale data will show you the normal distributions, because in Likert scale the people are on either side. Either all of them are on this, most of them are on disagreement side, or the most of them are on the agreement side, as you have seen here. Once we perform the frequency distribution, that is quite clear from the frequency tables that most of the here you see in the 3 questions which we have obtained the frequency tables, the most of the respondents are towards the agreed and strongly agreed side, and lesser the public as toward the disagree and strongly disagree sides. So when this situation is there, it's possibly data can never present the normality. So in most of the cases when the data are showing the normality, for the significance test, we use the non-parametric test. So I would suggest Jawad and the other management, if anybody is with us, that the next session we should have a workshop for the 2 hour or 3 hour session for the non-parametric techniques in the statistics. So all of you should be well expert in that. Mainly, we'll be discussing the parametric approaches today because of the time constraint. We cannot discuss the non-parametric, but I would suggest that after months or so, or whenever convenient, we should organize a workshop for the non-parametric techniques, because we people are quite weak in application of the non-parametric, but the accurate techniques when the non-normality is not present in the data is the non-parametric. So we should be expert as well in the non-parametric approaches as well. So now we go ahead with the brief descriptive analysis. So for that, I would suggest to use the explore command here, explore. So in the explore, you can, I will select the 2 of the variables A1, A2 only, because otherwise we have the bulk of junk on your output and we feel it quite uncomfortable to explain and interpret them. So I'm just selecting 2, but you can select all together. And now I have selected the 2, and we want both the statistics and the plots. So if you select the plots option, so stem and leaf we uncheck, because it creates a garbage on your output and unnecessary output. So normality plots with tests we should prefer, and continuing and then pressing the OK button. So here we have our output. So the main descriptive measures that you should discuss here, and you should include in your thesis or reports or whatever the document you are preparing. So for item to item descriptives, you should include the mean, which is 3.94, and 3.94 is very close to 4. It means your average response for this particular question, which is I have real opportunities for the career development in the university, the most of the respondents are 4, and 4 is indicating agreement. And then we should use median. So median is 4, exactly 4, and that is indicating you the average responses. Why we prefer the median? Because as you see that I said the Likert scale data are usually non-normal. So when there is no normality in your variable, so preferred average is median instead of mean. So that's why I just suggest you to include the value of the median in your analyses or the table you create for the descriptive analysis. And then we have standard deviation. Standard deviation is 1.11 if you round it to 1 decimal place. But the standard deviation, the main advantage of the standard deviation is you just have an interval of the mean plus minus standard deviation. Because if you look at the properties of the standard deviation, and particularly the property of the sigma limits and 1 sigma limit, 2 sigma, 3 sigma, so you just come to know from that property of the sigma limits from the standard deviation that mean plus minus standard deviation, if you create an interval such as the mean is 3.94 and plus minus 1, it means that you subtract 1 from 3.94 and you add 1 to 3.94. If you add it, you get 5, and if you subtract, you get 3. So an interval is formulated that is 3 to 5. So 3 is basically a neutral point, and 5 is your last ending scale value, which is strongly disagree. So you can conclude on the basis of that 1 sigma limit that almost 70% of your respondents are lying in this interval, which is 3 to 5. So when you leave the neutral part, which is if your responses are getting on average more than 3, it means you are slightly moving toward the agreement. So 70%, almost 70% are people who are indicating the agreement. This thing we come to know while using the mean and plus minus standard deviation. And another descriptive value for the dispersion measure, I would suggest you must use the interquartile range, and that is 1. So whenever you create and construct the tables for the descriptive analysis of these items, under every construct, you must use 4 descriptive measures. For the average, you should use the mean and median, and for the dispersion, use the standard deviation and interquartile range. So, and other than these 4, it's up to you that if you want to use the maximum, minimum, etc., whatever you want. But these 4 values are very important and mandatory to include in the tables. So similarly, for the other question, as you see, the mean is 3.92 and the median is exactly 4. The standard deviation is 1, almost 1.01 is rounded to 1.1. And then interquartile range is also 1 here. So the same interpretation can be given for that item 2, that 70% of your respondents are on agreement side, etc. So now we slightly move to the normality test. So as I mentioned earlier that this is a Likert scale and it's not possible to have normality. So now question is how you come to know whether the 2 variables, which is the A1 and A2, are distributed normally or not. This is determined through the p-value of your Kolmogorov-Smirnov test, that is KS test. This is the p-value under the column of the significant, that is 0.000 and 0.000. It is significant. So question is when it is significant. The answer is in case your this significance value is less than 0.05, you consider it as significant. And you see here it is 0. Mean this is significant. This question is also significant. And now the next understanding is whenever the Kolmogorov-Smirnov test is significant, your concerned variable follow non-normal distribution, is not normal. And as I explained earlier that Likert scale are merely normal distributed because of the tendency of the data is on either side of on the negative side or the positive side. So it's not possibly that all the legends are justifiably that most of the people are on neutral and then partially on the negative side and partially on positive side, then it can be normal, but it never happens in the Likert scale variables. So our tests are also declaring that these are non-normal. So whenever your data or the variables are non-normal, the preferred average is median and the preferred dispersion measure is interquartile range. So similarly, you can make the calculations for the other items of the data. And now here we have some graphs. We don't need to consider these graphs, rather you should look at this box and whisker plot. So this is box and whisker plot for the first question. And down there we'll have the box and whisker plot for the second variable. And it's a very surprising shape we see over here. So this is a particularly for the second question. And you see what is missing here. The lower whisker is there. And there is no upper whisker. So you see here, this line is a bit bold as compared to this. It means your quartile 1 and median are same here. So if you calculate the quartile number 1, it is 4 and your median is also 4. It means because this line is thicker, the bold as compared to this. So this is your upper quartile value. And there is no upper whisker available. It means that your quartile number 3 is 5 and there is no any other value other than 5 because your last value, which is the maximum value, is also 5. So from that box and whisker plot, you realize that only 25% of your values are below 4. It means your 75% of your responses for these questions are on agreement side and either on strongly agree. But the 25% of your respondents are below the value of 4. And you know what is 4? 4 is your point, which is showing you agree, and 5 is strongly agree. And your 3 is, you see, your neutral point. So your 25% of your individuals or the respondents are on the neutral point, and few are on strongly agree and strongly disagree and disagree side. And what these are, you see, we have 3 entries for the one, and these entries are 1013, 1012, 1011, and few entries we have for the uh, disagree, and these are also 3 entries, 1006, 1007, and 1008. So these only 6 entries are indicating strongly disagree or the disagree, whereas the rest of the data are taking 25% values on the neutral point, and the other 75% are respondents who are either agree or strongly agree. So that's how this box and whisker plot can be interpreted. And actually, I would say that is a post-mortem. It performed the post-mortem or the autopsy of your data, uh, how important these box and whisker plots are. So exactly the same tendency you can observe from the question number 1's box and whisker plot, that we have these 3 entries for the disagree and we have 3 entries for strongly disagree. Whereas your quartile 1 and your median, because this line is indicating the thicker one as compared to the last one, and there is no upper whisker, it indicates that your quartile number 3 and your rest of 25% data all are signing at strongly agree, and 75% of your respondents are signing at agree or strongly agree, and only 25% of the observations are indicating neutral point, and 6 entries are showing disagree and strongly disagree. So you can see that your most of them, 80%, almost 75% of your respondents are agree or strongly agree with this data. statement, and that statement is I have real opportunity for career development in the university. So that's how you can calculate and draw the box and whisker plot for the other questions of the construct, and similarly you will interpret in your write-up. So quickly, if you want to ask any questions, just go ahead very quickly, because we are short of time. So many things are to be covered yet. So no question. It means we go ahead with. And now we move towards the other part of the descriptive analysis. Um, Many people emphasize on this kurtosis and the skewness statistics, but actually I would suggest you to don't waste your time on the skewness and the kurtosis, because these two descriptive statistics are to measure the normality in the data. And once we have a particular test with us that can measure the normality, such as your normality test we have performed over here. So what to use of these skewness and kurtosis, etc. Because something is non-normal, it means skewness is present there, and maybe there is kurtosis issue as well when there is non-normality in your data. So for the item to item descriptive analysis, I would suggest you to avoid the skewness and kurtosis statistics. But once we calculate the score, and scores are determined, and we perform the descriptive analysis of the scores, then to some extent we can discuss the kurtosis and skewness. But if the presence in the presence of the Kolmogorov normality test, again I would suggest that don't waste your time on skewness and kurtosis, etc., etc. So in your box and whisker plots I have just discussed, these are indicating you the extreme values or the outliers. So if you have 1014 entries and only 6 outliers are there, so these are usually the people who are, angry with the world and angry with everyone, and they are never agree with anything. So these can be considered as some of the isolated individuals. So in the presence of these 6 isolated cases, you can calculate the rest of the information. These are not going to disturb at all your findings. But otherwise, sometimes it happens that there are many outliers or extreme values in your data. So your objective is just to go through them and deeply dig up the reason why there is so outliers. And sometime you see these are due to the wrong data entry. This also happens due to the wrong data entry. While pressing the key punch, instead of 6 we press 8 or 9 or something else. So the wrong data value sometimes represent the extreme value. So such type of the discrepancies can be located and can be removed in case such outliers are considered. But most of the cases, such as in this situation, only 6 individuals are appear to be the outliers. So just leave them, and you go ahead with the remaining part of the analysis. And now we just go ahead with the calculation of the scores, that how you can calculate the score for the construct. And keep in mind that scores are calculated that once you are quite confident that your construct is reliably measuring the tendency, and that can be measured through the Cronbach value. So the Cronbach value, if it is greater than 0.70, it means your construct is strong enough, and you can now go ahead with the score calculation of that particular construct. And now you see how we calculate the score. So going back to the data sheet, and now we'll go in the transform and the compute variables. And in the compute variable, the first variable, I name it as a job satisfaction. So job dot SAT, job satisfaction. And now once you assign a name to the variable, then you switch to the other part of your calculator. And here you are supposed to select a method, and that method is statistical, and within statistical you should use mean or median, either you can select. So better is to take the mean. So I have selected the mean. So once I select the mean, here we have two question marks, and in between the question marks we have a comma, and comma is indicating that whatever the items you choose over here, they should be separated by the comma. So that's why this format is in front of you. So I just remove these comma, and one by one I will select all these 5 items which are uh, measuring this job satisfaction construct. So here we have A1, then A2, then A3, A4, A5, and this ends with a construct. And now I will separate all these items by using the comma operator on the keyboard. You see, I have separated them using the comma. And as you have done this, and there is nothing else other than the usually requirement of the syntax to apply the mean, you just press the OK button simply. So once you click on the button, it will execute, and you look at your output screen. It shows that compute the mean executed, and go back to the data sheet. And in the data sheet, if you look at the variable view, you will see a variable that is created just by calculating the score, and that is job satisfaction. And in the data view, you can see also, after all these variables which are already in the data sheet, you will find another variable name as job satisfaction, and it has calculated the average for each of the respondents' job satisfaction score. So similarly, we'll be calculating the other scores of the constructs. And the next is the university vision. So I call it as a UV. So going back to the calculations, compute variable, and now it is university vision. University vision, and now I just delete all these items which are already selected, and now I'll begin with the B questions. And here B1, B2, B3, B4, so 4 B's only. So this is a B1, B2, B3, B4. And now let us separate all these B's by the comma, B1, comma, B2, comma, B3, comma, and press OK button. So it has created another variable, and now go back. And now the next construct is teamwork, the C1, C2. So deleting all, naming teamwork, name the new variable team work, teamwork. And now C are the C1, C2. So it's only 2. So comma to separate C1 and C2, press the OK. This is also done. And switching to the other independent variable. So the next independent variable is quality and internal customer. Okay, so I will name it as Q and IC. And we have all the question with the D. So name it Q and IC, quality and internal customer. So first we delete these items, and then we see where the D is. yeah, here. So D1, D2, D3, D4, D5, D6, D7, D8, D9, D10, and this is E, so we delete E, and we separate all these items by the comma. You see we have separated. Just press the OK button, and it's also calculated. And the next independent variable is employee. So these are related to employee benefits or autonomy of the employee. These are basically measuring the autonomy of the employee, that how much authenticated or authority an employee is enjoying on the present post. So changing the variable as EMP, I'm giving name as EMP. So deleting all, and then we have all the questions with the E. So this is your E1, E2, E3, E4, E5, E6, E7, E8, E9, no, it's F. So deleting F because not relevant to the construct. So E1, comma, E2, comma, E3, comma, E4. No. So these are done. Pressing the OK. And then compute variable. So the other construct is after the employee is a benefit, and the last is T and development, training and development. So so you see here, these all constructed have been scored with the calculated score. So benefit with the F code. So benefit deleting the previous. So here we have F1, F2, F3. No, G is not relevant. Comma. Then okay, it's done. Again, going back to compute variable. So it was training and development, training and development, T and DV. So we have last two items for the training and development. And these are G1, G2. This is G2. And see, now we have calculated all these variables in your data sheet. So job satisfaction is your dependent variable and all others are independent variables. So for your own convenience, what you do here, I just assign an underscore and D. D stands for the dependent variable. And here I just assign as I independent variable. For first independent variable, this is underscore I2. Second independent variable, third is I 3 is a third independent variable, and I4 is your fourth independent variable, and this is your I5, the fifth independent variable, and this is I6, the sixth independent variable. And don't forget to press the save button on the step-by-step technique so that the work can be saved. And now next step is we move towards the descriptive analysis of one by one these dependent and independent variables. So for tutoring purpose, I will just pick one, which is job satisfaction. I will analyze it, and similarly you will interpret the other parts as well. And now this is the job satisfaction I choose for the explore. So here I just deselect the previously selected and select one of the question variable, which is job satisfaction here. And we go ahead with the remaining selections as already done. So this is explore, and its interpretation is almost quite same as we performed earlier. So the mean of the job satisfaction is 3.9. So 3.9 is very close to 4. It means your most of the respondents are satisfied, with agree with the job construct and the questions asked in the job satisfaction construct. The mostly people are agree, and the median is 4, is the same. If you look at the standard deviation, it is 1, means the most of the people, 70% of the respondents are indicating agree, neutral, or strongly agree. So viewer would be indicating you the neutral point, but the most of the respondents are for the agree and disagree. And so far as the normality of is concerned, you see here, again, I mentioned that Likert scale is rarely possible that you get your job satisfaction normally distributed. So again, you can see that no normal, because the p-value is significant. Kolmogorov-Smirnov is significant. It indicates that this score indicates non-normal pattern. So similarly, you can calculate the descriptive analysis for the remaining independent variables we have with us. So this is your box and whisker plot, and we have a few extreme values which are below 3. It means these are the individuals, which indicates the negative side of the construct, which is disagree or the strongly disagree with the questions asked in the constructs. But so far as the main data chunk is concerned, so you see here this line is thicker than the quartile number 4. This is actually quartile number 4, but luckily we have upper whisker over here. So this lower whisker is though showing much of the variation, but it is the lower whisker is starting from the 3, which is the minimum point, and the maximum point where the lower whisker is ending is 4. It means that 25% of your individuals are just indicating a response in between neutral, and they are moving towards the agreement, because and now they are slightly moving towards the agreement. But the 4 is the point which is purely indicating the agree, and the 5 is the disagree. So above that point, which is the beginning of the box, because the box containing middle 50% of data and the upper whisker is containing 25% of the data. So collectively, from this point to the end of the upper whisker, there's a 75% of your observations. So the same is the finding that 75% of your respondents are 4 or above. So 4 or above mean 4 is your agreement point and the 5 is your strongly agree, and there is no any data value above 5, because the last code we have maximum on Likert scale is a 5. So that's how you can interpret the descriptive statistics of on the basis of that box and whisker plot, that your job satisfaction, the 75% of your respondents are either agree or strongly agree. So that's how you interpret. So similarly, you can calculate the descriptive measures for the independent variables, and you can write up accordingly as I have explained in front of you. And once again, we check with the agenda that now, as we see, we have discussed the basic descriptive and extreme data. Reliability is done, scores are calculated, understanding of framework is done, descriptive statistics of the data is done. And now what is remaining with us is this cross-tabulation and chi-square that we will perform end of the, once we complete all these things. After that, we'll cover the tabulated score, because I will use some library data for that for your own better understanding. So correlation analysis and regression analysis and t-test application in ANOVA. Now let's begin with these some of the things. So first of all, I will mm, use the correlation, but before moving to the correlations, uh, just explain. I just explain the comparative analysis by including these demographic variables. So I'm going back to the explore where I have chosen the job satisfaction. So now here we have a factor list, and basically that factor list is for the comparative analysis. And this comparative analysis you can perform on the basis of some of the demographic variables. So let's include the demographic variables, which is D2 as the academic and non-academic. So let me include the academic and non-academic here. And now I just prefer only the statistic instead of the bulk of the plots and the graphs in front of me. Now pressing the OK. And now what would be the result of this output? This result of the output would be that SPSS will calculate the job satisfaction descriptive analysis for the academic and non-academic separately, so that we can have a comparative analysis for these two categories of the employed people. So pressing the OK button, so you see here, so it has separated the two people who are academic and non-academic, and we have separately mean value of the academic and non. So mean of the academics are 4.00, whereas the non-academic are 3.87. So it means you can say that the academic side people are more agree as compared to the non-academic. And similarly, if you look at the median, it's a 4, and also here the more 4. So 4 is not indicating any difference, but actually the mean is clearly indicating that academic people are more satisfied so far as the job satisfaction are concerned, and the non-academics are lesser. There can be so many reasons behind. You see, there are more politics involved in the non-academic side, because they sit 9 to 5 in the offices and interact more as compared to the teaching people, because they most of the time interact with the students and go class to class, and sometime in the office sitting, and most of the time they are inside the class. But the non-academic people, they usually throughout the day sit in their offices, so they have more problems which come across them as compared to the faculty who is totally involved in the teaching. So there can be anything, but so far as the descriptive analysis is concerned, that we are about to describe it, what difference we find, we just describe. So on the basis of that, this is 4.00 and this is 3.87. It means that they are more satisfied as compared to the non-academic. And so far as the other demographic is concerned, so let us go back and include that universities over here to see which of the university people are more satisfied. But it will be jointly academics and non-academic. But if you include here At the same time, simultaneously, the academic and non-academic, it will be creating a 3 into 2, 6 categories by indicating each university and then academic and non-academic. So that would be more comparative analysis for you to write up something about the academic and non-academic comparison. So you see here, the UET is 4.1, the PU is 3.89, and LUMs are 3.5775. So if you compare the job satisfaction, it means the UET people are more satisfied. And after that, the ranking, the second ranking is the PU, is a 3.89. And the last is the LUMs, which is 3.75. Though all of them are showing you the satisfaction, but for the comparative analysis to see which of the university employees are more satisfied, so you can see that UET people are more satisfied, and then on the second ranking we have Punjab University, and the third ranking we have LUMS. So that's how you can write and mention in your interpretation for the articles or whatever analysis you perform, etc. And now at the same time, I'm using the second demographic simultaneously here. And now you see what happened uh, after clicking the OK button. So you see here, as I have clicked on, so it will now split the job satisfaction of the UET with respect to the second. You see, these are above there we have academic, and down there we have non-academic. So if you look at the job satisfaction of UET people, so these are for the academic people, which is 4.12. But if you look at the non-academic of the UET, you see what we find here. So these are 4. So almost you can see that the academic people are more satisfied as compared to the non-academic are lesser compared to the academic. And now if you compare the PU, so PU, the academic people are 3.89, and the satisfaction average for the non-academic in the Punjab University, they are 3.87. So 3.87, and above there 3.89. So though there's very marginal differences, almost same is the tendency between the academic and non-academic. So in the LUMS, the academic people are 3.75 on average score of the satisfaction, and look at the non-academic of the LUMS. So as you see here, this is for hmm, hmm, non-academics. In the non-academics, this is something overall. So which institution it belongs to? Something went wrong with the output. So, so ultimately, it is providing you the For the academic people separately, these are separating, and non-academic, these are separately explained. And more of the comparison or the comparative analysis, you can use the split command in the SPSS. So by split command usage, you can have the more better results. So I just show you that how you can use the split command for the comparative analysis. For that, you can use the data, and then we have split file. So in the split file, you want to compare groups. So first you use the university, and then we have academics, and pressing the OK button. So as you press the OK button, it will split the file compared to the college ID by the group. And now in the descriptive analysis, where you analyze and descriptive analysis, the descriptives, select the descriptive, and in that descriptive, we choose the job satisfaction here and just click over the OK button. So here you will have all the the main descriptors you have over here. So in that data, we have a breakup of academic and non-academic within UET, academic, non-academic within PU, and academic, non-academic within LUMS. So what is here? So in the LUMS, the mean of academics are 3.77, whereas non-academics are 3.73. So it's almost same. In the Punjab University, the academics are 4.03 and the mean of non-academic is 3.83. So the non-academics are lesser satisfied. And in the UET, entirely different picture is with us, that non-academics are more satisfied as compared to the academic side people. So that's how you can have a comparative study by using that split file. So whenever you apply the split file command, this is actually executed to have a comparative analysis. So unless you switch it off, it will always separate your all the results whatever you execute on the SPSS. So always switch off it once you have purposely applied the split from command and the results have been obtained, then you should off the split. So how to off the split? Then you will go back to the split file, and then again you will choose the radio button option here, which is analyze all the cases and do not create groups. Once you switch back to this one, then it will glow off. The splitting criteria is now switched off. Then don't forget to press the OK button. And as you press the OK button, you will find on your output window that split file is off. So here split file is off, indicating that there is no more split available at the for the next analysis you perform. And now you can perform the other and execute the other methods on the SPSS. And now we go ahead with the correlation analysis. Now in the correlation, we can measure the relation between the dependent variable and the independent variables, and in between the correlation of the independent variables. So first of all, we go ahead with the simple correlation. It's the bivariate correlation. So here, analyze, correlate, and the bivariate. So in the bivariate correlations, you choose the job satisfaction along with all independent variables. These are selected at once, and then press the OK button here. See, so this is correlation matrix or the correlation tables. So you can learn it using the entries on the upper diagonal side or the downward, there's a lower diagonal side. These are symmetrically indicating the results. As you see here, this result is similar to this result is similar to this. So either of the side of the diagonal you can choose for the calculation understanding. So these are the correlation matrix. So first of all, we are interested to see that how our independent variables are correlating with your dependent variables. So here we have a dependent variable, and one by one you see here, this is the first independent variable. So first independent variable is correlating with the job satisfaction very strongly. 0.972, 0.958, 0.962, 0.945, 0.949, 0.959. All these independent variable are very, very strongly correlating with your job satisfaction. And something more about these correlation measurements are the significance of the correlations. You see here, the first row, these are indicating you the correlation, Pearson's correlation coefficients. So these are Pearson's correlation coefficients. So this is a Pearson's correlation coefficient between job satisfaction and university vision. This is correlation coefficient between teamwork and job satisfaction. This is coefficient of correlation, the Pearson's correlation coefficient between quality and internal customer and the job satisfaction and so forth. You can say that all others are similar. And now the second row is indicating the significance of all these correlations. So once we have this p-value less than 0.05, it means significance is there. So this correlation is significant. This is also significant. This is also significant. This is also significant. This is also significant. And also, so it means all these independent variables are very, very strongly correlating with the job satisfaction. And now what the steps the university people should take, that if they want to control the job satisfaction of their employees, they should work on all these independent variables which are properly in their control, that they can give a better university vision to their employees. They can create a better culture of teamwork. They can give the better quality and internal customer importance in the environment. They can give a better autonomy to the employees, and they can give a better benefits so far as the financial benefits or the fringe benefits, salary, etc., and training and development. So once they improve all these factors, ultimately the job satisfaction of their employees will be increased, because all these are showing very strong correlations. And now look at the other parts, I mean how the other mm, mm, variables, the independent variables are correlating with each other. So for example, university vision 1. So university vision 1 is with the teamwork. It means if the vision is getting improved, or the vision is getting stronger and stronger, the teamwork will be stronger, the quality and internal customer will be stronger, the employment autonomy would be improved, the benefits would be improved, and the training and development would be improved if the university vision is improving. So that's how you see all these independent variables are interconnected with each other. And now I give you an example, because I'm switching to the next part of your correlation, which is known as the partial correlations. So partial correlation is actually the correlation. Before that, I just shared you an example, because you find uh, a buggy is being several horses are pulling it. सही है. अब उसको 3-4 घोड़े जो हैं वो मिलके जो है वो खींच रहे हैं. ठीक है. तो अगर आप देखेंगे कि जी what is the power consumed by the horses, and then what is the speed of the buggy running on the road, तो ये बड़ा उसमें एक पॉजिटिव कोरिलेशन आएगा और बड़ा स्ट्रॉन्ग कोरिलेशन आएगा कि जी जितनी ज्यादा ताकत जो है, द पावर हॉर्सेस आर बीइंग यूज्ड, उतनी ही ज्यादा उसकी स्पीड बग्गी की आ रही है. अब ये तो एक कलेक्टिव फोर्स जो है वो आप मेजर कर रहे हैं, जबकि तमाम के तमाम हॉर्सेस जो हैं दीज आर पुलिंग दैट बगी। लेकिन अगर आपने ये देखना हो कि ये जो उसकी स्पीड है बग्गी की, उसमें हॉर्स नंबर 1 का क्या कंट्रीब्यूशन है, ठीक है, जबकि उसके साथ बाकी 4-5 हॉर्सेस और भी काम कर रहे हैं, तो पर्टिकुलरली व्हाट इज द कंट्रीब्यूशन ऑफ योर हॉर्स नंबर 1, and now what is the contribution of horse number 2, particularly so far as the speed of concern in the presence of the other horses. तो ये अगर हमने काम करना है, so that purpose you should use the partial correlations. So how we calculate and interpret the partial correlations? The partial correlations is basically the what is the correlation between job satisfaction and the university vision when or in the presence of teamwork, quality and internal customer employee autonomy, benefits and training and developments. Or in other sense, you say if all these other independent variables are well in control, now what is the relation between the job satisfaction and the university vision? So that would be the correlation purely between job satisfaction and university vision when the others are in control. So that's how you calculate the partial correlation. And I would suggest that partial correlation will provide you the better picture to understand the contribution of your each of independent variable towards the job satisfaction. And now you see how we calculate the partial correlations. So first of all, you go in the analyze and then correlate and partial correlations we have here. So mainly you select the variables for which you want to measure the correlation, that is the university vision and job satisfaction, then university vision, and all other independent variables are will keeping for controlling for. So these are in the presence of these variables, how these two variables are correlating. Now pressing the OK button, you see previously the correlation between job satisfaction and university vision was 0.9 something. You see here how this is misleading, 0.972. But once you are calculating the pure correlation on the basis of the university vision, then it is 0.479. It is positive correlation, significant correlations, but it is now indicating that it is not that strong as we have calculated in the Pearson simple correlations. So that's how it provides you the better picture of the relation between these two variables. And now one by one we'll be doing it. So university vision is to be shifted over here, and now we select any other independent variable like teamwork. And now similarly, you see the teamwork is 0.215. You see its correlation is significant, though it is significant and positive, but previously it was 0.9 something, but here you see it is 0.215 only. See, and now calculating the, now we use the quality and internal customer over here and shift the teamwork down there in the controlled section. And you see again, the quality and internal customer is 0.213 and previously it was more than 5. And now you see you are calculating the power of each and every horse separately. And so far we have calculated the correlation. It comes to know that the horse number 1, which is university vision, as the most powerful horse, you see, which is pulling the buggy. Whereas the others which are previously indicated very strong, they are consuming a lot of power, but actually they are not using that much power. You see how realistic the partial correlation is. And now let's move to the other independent variable. Now I'm sending back this one, and employee. Take the employee. So this is basically the employee autonomy. You see, employee autonomy is though significant, and previously it was positive, but now it is indicating that it is negatively correlated with job satisfaction. That employee is more authoritative, the job satisfaction is decreasing. Now, there can be anything related to the human resources. They can explain it better that once the people are more authoritative, then what happens. So what I think in simple Urdu अगर मैं explain करूं तो जिस जगह मैनेजर ज्यादा हो जाते हैं फिर वहां पे काम करने वाले लोग थोड़े हो जाते हैं, तो वहां फिर ये डिमोटिवेशनल कल्चर जो है ना वो क्रिएट हो जाता है. दैट माइट बी द रीजन. लेकिन देखो कि ये हाउ इट इज, you know, realistic as compared to the previous. It was positively correlated. You see, it was 0.945 positively correlating with job satisfaction, but now we are particularly calculating the force by the employability, employee authority, so it is negatively correlating with the job satisfactions. So it is quite crucial and very alarming. And now switching to the next. Now we shift the employee here and take the benefit from why it is so. We might have created something wrong. So let's calculate the employee once again, because I think once again we calculated. Sahi, correct. Now employees are shifted down there and benefits we considered. You see, the benefits are not creating much of the relation between the job satisfaction here. It means people are considering other than money in the organization for their job satisfaction. It quite visible from that relation, though it is significant positive correlation, but it is very weak. And now benefits are shifted down there, and what is left now to consider? Benefit, training and development. Training and development is quite better. So it is positively correlating. And now you have very clear picture with you. So the partial correlation with the first independent variable is 0.479. It is university vision. And then we have strong the employee authority, but it is negatively correlating. So, and the next on the third ranking, the independent variable that is playing a strong role in your job satisfaction is your training and development. So if the universities are focusing these three main variables, that is training and development and university vision and the employee autonomy. So if they have a better control on these three factors, they can better control the job satisfactions. So that's how. And now I think every one of you, if you are doing such exploratory research or confirmatory research, you will prefer the uh, partial correlation instead of the simple correlations. And I have seen hell of the research articles where they are using the Pearson simple correlations, and on the basis of that they are developing different theories, etc., etc., and the papers are published. But that is the wrong analysis, unrealistic analysis. So I want you people, if you have any question on that, quickly, because we are running short of time. Please go ahead if you have questions. No question? Okay. I think it's pretty clear already. So now review back the agenda, and now what is left as correlation is done, and now regression. The regression is basically a modeling, to create a model where you can estimate the job satisfaction while plugging in your different values of independent variables. So this is the regression analysis, and the regression, how we can perform the regression analysis in this particular data. So let's move to the regression. But before moving to the regression, some of the important assumption that are mandatory to run the regression, I must explain that your dependent variable or the response variable should preferably be normal. That is the first important requirement of your regression analysis. But here, in our case, our dependent variable is showing no normality. So the preferably regression should not be used over here. So in case we apply the regression model, so that model cannot be a good model. And why it cannot be good model, that is ultimately due to the reason I have explained, that our dependent variable is showing the no normality. That's why your model cannot be very good model, but it can somehow present the picture of the model and the relation of the all collective independent variables over your dependent variables. So I go ahead with the regression in the absence of your main assumption of the regression, which is the normality. So here we have regression analysis, analyze and regression, and the linear regression. So in the linear regression, you click on the dependent variables. So you will choose the dependent variable. Here we have our dependent variable, and all independent variables are to be selected in the section of the independent variables here. That's the simply you choose the variable to run the regression model. This is a multiple linear regression model because more than one independent variables we have in our picture. So statistics, in the statistics, you should check here collinearity diagnostics and the Durbin-Watson. That will indicate you in case there is a multicollinearity issue. Multicollinearity issue is sometime your independent variables are correlating with each other, and that problem is lying in our data, that our variables are highly correlating with each other. So to detect that if they are dangerously correlating, then this will indicate And one more thing is the serial correlation, the Durbin-Watson test, that whether the serial correlation or the auto correlation tendency is lying in our data is determined through the Durbin-Watson test. And now I'll just explain that what are the thresholds to see all these descriptive tests or the diagnostics tests. We just go ahead with the OK button to see the output of the regression model. So step by step, I move. You see here, this is the first table that is showing you the first value as capital R. Capital R is known as multiple correlations. Multiple correlation mean if these all independent variables are jointly combined, then how these would be correlating with our main dependent variable, which is job satisfaction, is 0.98. So it is quite good value. And now R square is another yardstick to measure the strength of your regression model. And that is indicating you that once you multiply this value with the 100, so it turns to 96.3%. At the moment, it is 0.963. And if you multiply it by 100, so we get a value 96.3. It means 96% of the variation in your job satisfaction is being explained by these 6 independent variables. So only 4% of the variations we are unable to control through these all independent variables, but we are able to capture 96% of the variation in your job satisfaction through including all these independent variables. So adjusted R square is another descriptive measure which provide us the information that if you include any other independent variable, so our model can improve or not improve. So you see these values are exactly same. It means that if you include another independent variable, there will be no improvement in our model. So adjusted R square actually suggests you that you should include another variable or not. So it suggests that we shouldn't include another independent variable in the model. And the last value here in this table is the Durbin-Watson. So preferably it should be in 1.5 to 2.5. It should be in between 1.5 to 2.5. And as you see, this is not lying in your supportive band, which is 1.5 to 2.5. It means there is an autocorrelation problem in our model, and our model cannot predict any reliable value in case we use this model. Durbin-Watson is diagnosing this thing. And now the next of the table is indicating you the ANOVA. Actually, it is determining whether your model is significant one or not. So this p-value is significant. As I mentioned earlier, the definition of the significance, that once a p-value is less than 0.05, it is always significant. So on the basis of this p-value, we can say that our model is significant one. So it's very important that your regression model should be significant. In case it is non-significant, it means that model is not providing you anything useful. So leave that model. But here you can use to some extent the model because it is indicating you the significance. And now here there is a model summary that is indicating you many things. So while fitting the model, these are the model coefficients. And here we have significance of each and every independent variable. So the first independent variable is significant, second is significant, all these are significant. But at the same time, we have a big problem in our model, which is of multicollinearity. And the multicollinearity means the VIF. This is a descriptive measure which indicates the multicollinearity. And I usually say that in case your VIF is greater than 10, it means there is a problem of multicollinearity in your model. What you see here, 61 is this one, the VAF 61, 46, 21. The least value we have of the training development is a 17.15. So there is a big problem of the multicollinearity in this model, because all these independent variables are very, very, very strongly correlating with each other. So this model can mislead us in its estimations, and we should not use the regression model for uh, this type. The calculated model we should not use here for this data. So you should filter some of the variables from the analysis, so that a better model can be obtained from that analysis. And so how I will filter on the basis of the some of the partial correlations I have obtained before running the regression analysis. And we found that these variables are more important, such as the training and development. It is showing more partial correlations than we have the employee ability, and then we have first independent variable as a university vision. So let us include only these three variables in our analysis and exclude the others. So uh, teamwork we exclude, this we exclude, the employee was giving us a better picture, and training. So these three were having a better partial correlation values. And now let us run the regression once again by including only three important variables which are showing you the high partial correlations. And now we have something very good figures with us. You see here the R is 0.978. It is again showing very good figure, and R square is 0.957. So previously it was indicating 96% variation to be contributed by independent variables, and now again we have the same contribution, 96%, by including only three variables in our model. And R square is also adjusted, R square is also decreasing. It means we should not include any other variable in our model. So it is not suggesting to include any other variable. And the Durbin-Watson, to avoid the autocorrelation, previously its value was very small, 1.5, though it is small again, uh, indicating the same tendency which was lying in our previous analysis of the autocorrelations. That was 2 to 1, and now it is 0.20 something. And now let us see the other diagnostics. So again, we see that VIF is again showing very high correlations. And which of the variable are very strongly correlating with each other? You see here, the university vision and the employee, these are strongly correlating with each other because the VIF is very higher in front of these two variables, whereas the training and developments, this is a bit lower side compared to these two values. So another filtration process we should perform over here, and we exclude another variable from that analysis, and that is the employee. That is independent variable number 4. And now you see what happened to the analysis if you remove another variable. You see, by excluding this variable, again we are having a strong R square value, and R value and model is again significant, but some extent we have a better picture compared to the previous model. But again, you see these two variables are also correlating with each other, the University Vision 1 and Training and Development 1. So to model that data, it is better to use only one variable instead of two variables. So again, we run a filtration process and exclude the training and development from that. And now this is the model on the basis of only one independent variable, which is University Vision. And almost 94% of the variations you can contribute through this one independent variable, and model is significant. So serial correlation problem is still there, but multicollinearity issue is no thing because we are using only one independent variables. So the linear regression model will be suitable here if you want to model this job satisfaction through the independent variable. So the only independent variable to model the job satisfaction is the University Vision. So you can use that model for any of the, you see, prediction regarding the job satisfaction. But considering all this output, I would suggest you to don't use the regression model in this data. The methods we have applied so far in the correlations, which is partial correlation, is providing you all useful informations to check the relation between the dependent and independent variable, and there is no need to run the regression here. And now we have left with the analysis of variance to discuss and the T applications. So T test or the ANOVA, in case you are running the one sample T test, then the T test can be discussed over here. But so far as the independent samples T test are concerned, it cannot give you anything useful in presence of the ANOVA tests, because the independent samples T test and the analysis of variance test, they provide you the same informations. So how you can run the analysis of variance test here? First of all, you should know that why we apply the analysis of variance test. Actually, analysis of variance test is done to see whether on average the three universities here are different from each other or they are same. And if you run the analysis of variance with respect to the second demographic variables, so you can check the significance whether on average the job satisfaction is same for the academics group and the non-academics group. So just to check the significance of the demographic variables, you should use the ANOVA or the analysis of variance test. And one of the important assumption which is associated with the analysis of variance test is the normality of your data or the normality of your variable, response variable. But unfortunately, our all response variables are showing no normality. So analysis of variance is not suggested here. So as I mentioned well in the beginning, that we should all learn about non-parametric techniques, because non-normality is rarely present in case your Likert scale data are collected from the public or the target populations. But anyhow, just for the learning purpose, I will explain how to run the analysis of variance to see the significance of your demographic variables. So to run the analysis of variance, your response variable should be continuous, and your variable whose significance you want to see, they should all be categorical. And luckily, we have first demographic variables. It is categorical because it is indicating you the universities. The second is a group. Again, this is categorical. And the variables over which you want to see the significance of our demographic variables, these are all continuous type. And what these variables are: job satisfaction, these are all our variables over which you want to check the significance of our you see the demographic one. And now I apply the analysis of variance collectively on all these, you see, variables, and we check in which cases the universities are significant and in which cases these are not significant. So in running the analysis of variance, you will go to the compare means under the umbrella of the analysis, and then we have one-way analysis of variance. So this is one-way analysis of variance. So you can select all these variables together. You see, I have selected all these variables, and in the factor list, you will choose your categorical variable or the demographic variables, or it can be any variable, the impact of which you want to check on the uh, dependent and independent variables. So here some of the important checkbox we need to fill, that is descriptives and homogeneity of the variance. This also will check whether the variances are same or not same. So continue here and press the OK button. So this will show you the output of your analysis of variance table. So this is the descriptive analysis that will indicate the averages of all universities across all the variables, including dependent and independent variables. So I just explain it that in the job satisfaction, the average of the UET is 4.12, PU is 3.89, LUMS is 3.75, and the overall mean is 3.92. In the university vision, UET's mean is 3.96, PU is 3.93, LUMS is 3.69, and overall mean is 3.89. And similarly, you can explain the others. And in the descriptive analysis, you can see the standard deviations, standard error, etc., etc. Many other things are calculated in the descriptives. And now here you see, this will provide you whether the variance across the three universities are same in the variable or not. And this you can explain or determine from the p-value of this significance of the homogeneity test of variances. This is significant because less than 0.05. This is not significant. This is significant. This is significant. This is significant, significant. And this is also, you can consider it significant. So only one case is the non-significant case. And now how we interpret. In all significant cases, the variances in responses are significant. You can say that the variances of UET, PU, and LUMS are not equal in variances so far as the job satisfactions are concerned. In the university vision, since it is non-significant, it means the variances of three universities are same. Here it is significant. The variances of all three universities are not same. Variances not same. Variances not same. Variances not same, and in the last variable, variances are not same. So significant cases are those where the variances of three universities in the responses are not same, and where the non-significance is in the test of homogeneity, it means the variances of three universities are same. And now we look at what is the average response of the universities, in which cases these are significant. Less than 0.05, less than 0.05, less than 0.05, less than. All these are significant, all. What it indicates? It means that job satisfaction, the three universities average is different, mean the job satisfaction in three universities are not same. University vision in these three universities are not same. Teamwork is not same. Quality and internal customer is not same. Employee autonomy is not same. Benefits are not same, and training and developments are not same. It's very clear that how you can say that the Punjab University training and development environment is same as the LUMS, or the LUMS are similar to the UET. These are not same. It's quite clear, not same, and the same is evident in this analysis. So that's how you perform the ANOVA and the analysis of variance. You can say ANOVA is the analysis of variance. So similar analysis of variance you can perform, and now we will be changing our demographic to the second demographic variable, and now this test will provide us whether on average the academics and the non-academics are same or not. So you see what happened. Similarly, these are your descriptive analysis. It has been already explained. So, and you see these are the variances. So only the significant, non-significant case is the job satisfaction and training and development. Means you can say that job satisfaction variances are same so far as the academics and non-academics groups are concerned in these two cases, first and the last. Whereas in between, all these p-values are significant due to the less than p-value less than 0.05. So in all these cases, from University Vision 1 to benefit, which is I5, the variances in the responses of the academic and non-academic are different. Significant mean different variances, non-significant mean same variances. Variances mean scatter of the responses, mean how the people are scattered with their views. That is basically the variances. So when the variances are different, it means that scatter of the responses are quite dispersed. The people are thinking differently when the variances are more scattered. And if the variances are same, it means the people are thinking on the same, respondents are thinking on the same lines. They have very marginal differences in their views of looking the things with their viewpoint. And now, so far as the significance of the averages are concerned, this is non-significant, 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 and non-significant. Only one variable is showing significance, which is employee autonomy. It means that employee autonomy is different in academics and non-academics, and it is quite clear that the authorities, the faculty people are using, these are not used by the non-academic people, and the authorities used by the non-academic people, these are quite different from the authorities used by the faculty. So that's why there is significance that on average the employee autonomy is different. But so far as the job satisfaction is concerned, same between academic and non-academic. Vision is same between non-academic and academic. Teamwork is same, academic, non-academic. Quality and internal customer the same, means the non-significant means similarity in the average. Here the similarity in the average response of the benefits between academic and non-academic. Training and development opportunities, these are same on average between academics and non-academics. So you can see now by using the ANOVA that in which cases your demographic is playing a significant role and in which cases it is not playing a significant role. So far as the group are concerned, these are significant in employee autonomy, whereas they are not significant anywhere across all the variables except only one, which is employee autonomy. So that's how you can use the ANOVA and also variance to test the significance of the variables. So, and now if you review your agenda, the only left with us is your cross tabulation and chi-square. And I've seen the most of the sociology students are focusing on the chi-square. So that's why I am just discussing this chi-square separately. So before moving to the chi-square, so let me explain the chi-square's applications. Actually, chi-square is very similar to the correlation analysis. But in the correlation analysis, the main assumption to run the correlation analysis is that both of your variables should be continuous. Then you can calculate the correlations. But in case your variables, the relation of which is to be determined if these two variables are categorical, then you cannot run correlation. It's not suitable to run because of the structure and the type of the data. Then in this situation, you should run the chi-square analysis or chi-square test of independence. So first of all, I just show you the data that can be the most appropriate for running the chi-square analysis. Then we discuss its use, etc., etc. And now I'll be using a library file, and that file is the serial. So let us go to the library to open that data file. The serial is the file I will open. So in the C, here we have a serial. This is a serial file. You see here. And now what this file contain? This file contain how many variables? This file contain 1, 2, 3, 4, 5 variables. And what these variables are? The first variable is age category. It is categorical. Second is a gender, male, female. Third variable is marital status, married, unmarried. Fourth is the lifestyle. In the lifestyle, how many categories in the lifestyle we have? 2. Inactive lifestyle and the active lifestyle. And now how we can differentiate inactive and active lifestyle? If you are performing any white collar job, means you are just doing your job while sitting in front of the table and sitting on a chair. This is a non-active lifestyle. And whereas what is the active lifestyle? Active lifestyle is somebody who is constructing a building, somebody who is repairing the electric appliances like transformer, wires, etc. Laborious work where very active body is required, you can say, and more energies, more attention of the body is required. These are considered as active, whereas a teacher is doing not, that is inactive sort of, because you are using more the brain work, rather physical energies are not that much required in. well, I think, but the views can be different. And the last variable is a breakfast. So this is breakfast preference, means the breakfast bar, oatmeal, and the cereal. So these are the three breakfast options. It is just like एक जो बाहर मजदूरी करने वाला बंदा है, तो वो सुबह जो है वो 2 पीस और एक अंडे एक चाय के कप का नाश्ता नहीं कर सकता, बिकॉज उसने 5-6 घंटे बिफोर द लंच उसने मजदूरी करनी है, वजन उठाना है, नीड मोर एनर्जीज। वो 4 रोटियां खा के जाएगा तो देन ही विल बी इन पोजीशन टू वर्क एंड परफॉर्म हिज ड्यूटी, वेयर एज अ टीचर एक एक कप चाय का पिएगा, 2 पीस खा के आ जाएगा, कोई मसला नहीं, 12 बजे तक कैन वर्क. So that's how the requirement of the breakfast change with respect to the duties you perform. So यहाँ पे ये सारे सारे variables we have. And now let us differentiate which of the variables are ordinal and nominal. So it's very clear. The age categories. So you see as the codes are moving, the age is increasing. This is ordinal. And the gender is nominal. So male to females, 2 categories we have. Marital status, married, unmarried, it is not ordinal one. And active, inactive, these are lifestyles. So you cannot say is an ordinal one, these are nominal. And also the breakfast choices is nominal. So only one variable we have ordinal, and whereas the all other variables are you see nominal. And now if you want to and you are interested to see that what is the relation between the age categories and the breakfast, or is there any relation that in particular age group the people preferred a specific type of the breakfast, is there any relations? If you are interested to know such type of the relations, then correlation cannot work over here. And you want to see whether there is any choice that male are particularly selecting a specific breakfast and the females are different in making choice of the breakfast. And same is the case the marital and unmarried and married and unmarried, whether there is any difference of making choice of the breakfast कि married लोग कुछ और नाश्ता करते हैं, unmarried कुछ और करते हैं. So if you want to see the relation of such type, so you cannot do with the help of your correlations. So ultimately you will have to go to check this relation through chi-square test of independence of the attributes. क्योंकि जितने भी categorical type के questions या variables होते हैं, we call such variables as attribute variables, because they attribute certain characteristics and these characteristics are categorical. So that's why we call them an attribute. And now how we go ahead with this. So first of all, here we have a data, and first you should decide which relation you want to see. You should decide first. So for example, I want to see that age category. Is there any relation between the breakfast choice and the age category? These two variables I want to see the relation in between, and these are categorical one. So ultimately I want to apply the chi-square test of independence to see whether these two variables are relating with each other or not. I see how we can go ahead with the chi-square test. So it's a analyze and then descriptive and then cross tabs. So this is the route for the chi-square test. Analyze, descriptive, and cross tabs. So while clicking on the cross tabs, here we have row and columns. Mean one variable we are going to select across the row. So for example, I want to choose the age category across the row and preferred breakfast across the columns. So if you interchange them, there will be no difference in your chi-square result. These are symmetrical, whether you choose any variable across the row and any variable across the column. That is depending upon you, that which type or the shape of the table you want to see after the data is analyzed. But the chi-square value remain the same, whatever the arrangement you use. And now here, clicking on the statistics. So in the statistics, you should here that is chi-square. And then we have contingency coefficient. Well, you see, let's discuss it later on, but first we go ahead with the chi-square. And in the cells, it's better to have a percentage of the totals. Then you will have a percentage of each cell counts with respect to the total counts. So go ahead with and pressing the OK button. Now you see here we have chi-square table with us. So here you have age categories, and here we have breakfast preferences. So one thing is very important with respect to the chi-square, that these are called cell totals. These are cell totals, and these are totals. In the extreme column and extreme row, these are totals. And in between all these are cell totals of this cross table. This is a cross tabulation between two categorical variables. So this is a cross cell frequency of the individuals. Those are lying in age group 31 to 45, and their preference is the oatmeal. So I was just uh, making you alert that once you run the chi-square analysis, each of your cell count should be greater than 5. Shouldn't be less than 5. ये देखें नीचे लिखा भी है उसने. तो ये हमें कोई इतना, it is not disturbing us a lot, because its expected count is greater than 5. That's why it is not alarming us. But sometimes it happens that your expected count is less than 5. Then it gives you something, not a reliable value of the chi-square. But here we are better, quite safe. And now the first of the value is the Pearson's chi-square value. This is the value of the chi-square, 309.336, and its p-value is 0.000. It is significant. Why? Because less than 0.05. When chi-square is significant, you conclude that these two variables are related with each other. These are related with each other. That is basically the interpretation of the chi-square. Means there is a correlation between age categories and the preferred breakfast. And that is very easy for you to compare, that as you see that over age 60, which meal they are preferring most. They are mostly preferring the oatmeal. Okay. And the young people, they are going for the cereal and breakfast bar. But the older people are preferring the oatmeal. So that's why this is on the background of the cross table. But actually the conclusion is on the basis of the chi-square significance value. That significance value is explaining that the preferred breakfast is age dependent. The different age categories having a different preferred breakfast. So this is your chi-square test of independence. And now let us make a change in our choice for different analysis and different choices of the variables. So in the cross table, I go back, and instead of age, I use the gender. And now I want to see the relation between the gender and preferred breakfast. That is there any, difference between choices of the breakfast between male and female. So let us run the OK. You see here, this is output. What is chi-square? 0.505. It is non-significant. Chi-square is non-significant. It means male and females are equally selecting the choices of the breakfast. Mean there is no difference of breakfast choices between male and female. So that's how chi-square helps us in deciding whether the two variables are relating or not relating. So if you say gender and preferred breakfast are relating, so my answer is no, they are not relating with each other because of non-significant p-value. And now you see, you make another choice arrangement. And instead of gender, let us replace the married people and unmarried people here so far as the preferred breakfast is concerned. Highly significant. And now you can say that married people and unmarried people are having different choices of your breakfast. It's very clear that married people are usually preferring cereals and oatmeals, whereas the unmarried are, most of them are with the breakfast bar and the cereal. So their choices of breakfast are not similar. Why it is so? Because your chi-square is significant here, which is less than 0.05. And now let us discuss what this table is indicating, because it helps us in writing up the interpretation of the chi-square analysis. Now, what this 108 is indicating? It means there are 108 individuals, those are unmarried, and their breakfast preference is breakfast bar. Now, what this 95 is indicating? There are 95 individuals who are preferring the oatmeal, they are unmarried. 100 are preferring the cereal in a breakfast and they are unmarried. And similarly, you can interpret the other frequencies as the cell counts. And what is in the lying the total? Now the total, there are 303 individuals who are unmarried, irrespective of what they choose in their breakfast. And there are 577 married people, irrespective of what they choose for their breakfast. And down there in the columns total, 231. There are 231 individuals. Those are preferring breakfast bar, irrespective of whether they are married or unmarried. 310 individuals are preferring oatmeal, irrespective of whether they are male or married or unmarried. And similarly, 339 individuals are those who preferred cereal in the breakfast, irrespective of they are married or unmarried. And now what these percentages are indicating over here. You see here where we have 100%. We have 100% over here. The grand total 880. It means in this survey or in this data sheet, there are 880 individuals who were surveyed for these 5 type of the questions we discussed. 880 individuals. And out of 880 individuals, how many are male married? 66% are married, 34% are unmarried. Then look at here, 39% of the individuals are preferring cereal. 10.8, mean approximately 11%. So it means the 11% of the individuals, those are preferring oatmeal and are unmarried. These are only 11%. And here 27% of the individuals, those are married and prefer breakfast is cereal. These are 27% only. So that's how this is the breakup of this entire 880. So if you have a grand total of all these cross cell frequencies percentage, it will total to 100. And if you have a total of this column, this will be 100. Total of the rows would be 100. So in all the direction that should be 100. So it means that all these percentages are given with respect to this grand total. And where from this grand total is and percentages are coming, if you go in the cells and check this checkbox. If you use this checkbox, it means it will provide you all the percentages with respect to rows. If you choose instead columns, it will provide you all the percentages with respect to the columns. So in this way, you can make your choice accordingly. If you want to see the expected frequency, you just make a checkbox selected over here. So that's how you can check your and see your desired output on the SPSS output window. So this was something about the chi-square test of independence. So I have almost finished all. So if you have questions, please go ahead, because the question answer session begins now. I have finished all. Go ahead.
If you have any questions, you can unmute yourself and you can ask them.
So I think there is no question.
I think so. The way you have explained everything, there is no need for any further questions. But I think we have one question. When is it appropriate to apply ANOVA?
So when I was explaining the ANOVA, I mentioned few of its main assumption that your main variable over which you want to apply the ANOVA should be continuous and it should follow normal distribution. And the variable whose significance you want to check through ANOVA is usually categorical and should be categorical. But these are the important things when we are applying the analysis of variance. So looking at the data, present data, and it was from the social sciences and management, I would prefer that whenever next time you organize any of the workshop like this, we'll select the running of the non-parametric techniques. So because here in most of the cases, the non-normality was there. So really we need non-parametric techniques. So I think we should look forward to more of learning opportunities, and I'm looking forward to have a workshop on structural equation models. But it depends upon how much interest and the thirst is there within the department to learn all these techniques. But these are very important for sociology, psychology, and in management sciences people. And I'm saving this output file with you, and I'll share with you so that everyone can see what the output we have had throughout the workshop and application of different techniques. It would be very useful for them to learn whatever the output we have had. So other than um, here
So
we
there is
have
another question.
Aliza and Mary, yeah, related to the t-test instead of using ANOVA. Actually, the ANOVA is more robust because it is applicable to the two categories or more than two categories. Whereas if you use the t-test instead, the t-test provide us only the environment where you can test the significance of the variable having two categories only. So ANOVA is more robust and it is equally good. So that's why I have explained ANOVA instead of the t-test. And if you use the ANOVA and you avoid the t-test, it is equally acceptable. But I would say it's a more preferred and accepted as compared to the t-test, because it's more robust due to having its flexibility in the number of categories in our variable for which we want to test the significance. I think I have answered to Alizan, Mary. So can we close, Jawad?
Yes. Thank you, sir. I would like to thank you again on behalf of Population Research Center for sharing your knowledge with us. And I would like to request Dr. Vikas to say a few words.
Good afternoon, sir. Sir, I've been through hearing and watching the workshop. It actually was very helpful to me because some very important concepts were revised. So I want to thank you very much, sir, on behalf of the PRC and the PRC certification students for this wonderful work. Thank you very much.
Thank you very
sir.
much, Dr. Vikas, for your cooperation, for your support, and particularly Jawad, who has been throughout with me, and his help, his cooperation, and his sweet words by Dr. Vikas and Jawad, and thanks to all the students who remained with me and with us. Thank you very much. See you all later. Allah Hafiz. Bye bye.
Thank you everyone for joining. Those who have registered for this workshop will receive recording of this session soon, and they'll also get a certificate of participation. Thank you everyone for joining. Allah Hafiz.